accessible anymore because technology has moved on. And then, of course, the example of the 90s is very sad. A lot of data actually get lost, and a lot of effort is being lost in that way. So there are many examples of where it can go wrong. This is an especially sad one, I think. It's about a spreadsheet where the wrong conclusions were drawn, and it had actually significant impact on policies in the UK, where an austerity program had impact on real life. So transparency of data, good data management can really save lives. And for that, I have also some positive examples. A lot of research is now getting more open, and that can really make a difference. The crisis with Ebola in Sierra Leone was seen as a public health crisis, and data was made publicly available very soon. The same with the article on Alzheimer. In the article, they actually explained that what they did wouldn't have been possible if they wouldn't have shared data, because no single researcher or no single institution had the means to do the whole research. But with sharing results and sharing data, actually a lot of progress was made that otherwise wouldn't have been possible. And very current, of course, we have the COVID-19 research, and this is really accelerated in a big way open science. This global pandemic really showed where the strengths are of open data. So the European Commission had an open data platform. OpenAir as well facilitated the fast access to data, and this really made a big difference in how fast treatment could have been developed. So there's a lot of cases for good research data management and open data. So as said before, if you want to explain data management in a really simple way, it's really the way data should be presented is somebody outside of your project that finds your data, can easily understand your data, and can easily access your data. So you need to explain what your data is about, what you've done with your data, store it safely, and then, if possible, provide access. And what a lot of funders now ask for is a data management plan. And this really is a tool that can help you think and address these issues. Because if everybody explains their data in a different way, that also makes it a lot more difficult to figure out on your own what this data is about. Open data, on the other hand, it speaks a bit for itself, but there is a difference between open data and data sharing. So data sharing has been a practice in some disciplines for a long time, and it is sharing with restricted access. So whether that is in a specific discipline or under specific conditions, or if somebody asks for your data, you provide it. And there might be very legit reasons why you would not completely open your data. So open data is free to access, reuse, repurpose, redistribute the data for all purposes and for all people. So you wouldn't have to ask for the data. So that's a bit the difference. So I hope I made a bit clear why research data is important and what open data is and what's the difference between open and sharing data. And because the importance in this day and time of research data management, the European Commission decided in 2017 to start with what was then called the Open Research Data Pilot. It started off as a limited pilot, but became the default in 2017. And there were two main goals. One was to foster open science. As I said, open data is an element in the whole context of open science. And the second was to avoid duplication of research and loss of resources. Gathering data and managing data is time consuming, and so they didn't want to let this valuable research outcome go lost. So 2 main important pillars in this mandate. The first is to write a data management plan. And the second pillar is to give access to research data. So in Horizon 2020, you could opt out of this pilot completely, or you could opt out of the open access part of this pilot if you had a valid reason, of course, to not provide access to your data. The requirements of the data pilot were fourfold. So first of all, you had to write a data management plan, which explained what data you would gather or reuse, what you would do with the data, how it would be processed and analyzed, how it would be stored and where, what kind of access you would provide. So that's all the information that you write in a data management plan. And after the finalization of your project, you have to deposit your data in a data repository. This is a secure and sustainable way to archive data, together with the information needed to validate the results in your paper, so that people can actually look at your data, know what it's about. And then the fourth step is to provide access to the data so other people can actually access your data. All this is described in the FAIR Data Management Guidelines. It's a really comprehensive set of guidelines to fulfill the Horizon 2020 mandate. It clarifies the concept of FAIR data, explains what a data management plan is. It also gives a set of questions, so a template for a data management plan. It's quite excessive. It has a lot of questions. It's very detailed. But really, it kind of explains everything that you have to do. So in short, to give some steps and already hint to some tools that can help you. First of all, you have to write a data management plan. I think Ellie will talk about Argos as a data management plan tool. There are others. It's not a document that you make once and then it's done forever. You can update it when something new happens in your research project. Then step 2 is to find a data repository that matches your data needs. The best practice is to go for a disciplinary repository. If that's not available, there are other repositories. You can look at R3Data for an overview of repositories, R2Zenodo, which is a catch-all repository funded by the EC and supported by OpenAIRE as well. Step 3 then is to deposit their data, and as said before, the idea is really to make it a package that people can understand when they find and access your data. So use standard file formats that people can open easily with programs. Use standard metadata so people can find your data and understand your data. And use a license so people actually know what they can do with your data. If you need support, I mentioned the guidelines, and OpenAIRE as well is a great way to find more information on how to fulfill the open data mandate of the European Commission. So I talked a lot about FAIR data. FAIR is a guiding principle for the European Commission to make sure that the data that you deliver is of high quality and of a high standard. FAIR is really a bit the gold standard of research data, and it stands for findable, accessible, interoperable, and reusable. And I really like this example because it's quite funny, but actually some examples that I've read about are not as far away from the bad side. So findable means that it's findable online and not stored somewhere in a filing cabinet on the basement. Accessibility means that it's open for everybody, and everybody really means everybody, so no login. So not being guarded by wild badgers. Interoperable means that you use open formats, so you can use the data together with other data, and not that everything is written in Esperanto, for example. And reusable means that there's good quality metadata stored and that it's stored for a longer time, not that your data explodes. So to make it a little more valuable, so findable. Some questions that you have to consider there are, how can people discover your data? And if people can discover your data, will they understand what your data is about? Accessibility really speaks about where to find your data and how can I access it, can I open it? Interoperability really talks about using the data together with other data, so really preparing data this way. Reusability is about making it crystal clear what others can do with the data. So these are some of the elements that you have to consider when writing a data management plan. Findability will ask about what kind of metadata will you use? Will there be a persistent identifier? Is there a naming convention that is consistent? Are there keywords? Is there a version? So these are the things that will be asked in the data management plan for the Horizon 2020 project. Accessibility goes, is there documentation? Is there a data repository where you can go to, where all information is clear? Interoperability, said before, it's about standardizing, so standard file formats, standard vocabularies, standard methodologies, so data can be used together with new data. And reusability is mainly about licensing, so it's clear immediately what people can do with your data. So Horizon 2020 is ending, and we already know a little bit about Horizon Europe and what research data will mean there. So the EC is strengthening its research data mandate, and there will be a focus on research data management and the FAIR principles. Let me get a sip of tea. So there is a continuation in this open data mandate of the European Commission. The FAIR principles are very central. There's still so the data management plan is still a requirement, then to deposit data in a trusted repository and ensure open access. So this is a bit the same as in Horizon 2020, but there are some new things, some changes. It's no longer a pilot, so this means that every project will be asked to do this data management plan to make their data open. There's a real focus on research data management and FAIR data, because the European Commission understands that there may be legit reasons to not open data, for example, for privacy reasons, but there are no good reasons to not do research data management, to not manage your data very well. So open licenses are encouraged also for metadata, so not only for your data. And there is what I called here the EOS pilot. It's not an official term, so don't quote me on it, but it's a way to get projects to get familiar with EOS. And we'll talk about EOS in a minute. So one of the changes in the data mandate is that the EC ask some of the calls. There will be a condition that projects need to use a data repositories which is federated in EOS in compliance with EOS. So I mentioned EOS now a couple of times. Better explain what it is then. I'm involved in a project called EOS Pillar, and it's really a national effort to see how well 5 countries are how they are ready for EOS. And EOS is the European Open Science Cloud. And it took me a couple of presentations by other people explaining what EOS was before I really could grasp it. So I really hope that I can explain it in the best possible way. It's not an easy concept to grasp. But EOS, or the European Open Science Cloud, is set up by the European Commission. And what it does is it doesn't make new infrastructure, but it looks at the existing scientific data infrastructure, and it tries to build a virtual environment that makes it easier to find, access, and reuse research data, tools, and services. So now this scientific data infrastructure, or often on a national level or on a discipline level. And the European Open Science Cloud really tries to make links between these services and infrastructures and combine data sets in these infrastructures. It goes across disciplines and across borders, and it hopes to enable new and unexpected discoveries, and also to make research, data management, and finding data a lot more easier for researchers and projects. So the challenges that the European Open Science Clouds try to address is it really tries to give more access to data and results, which are now in different thematic repositories or national or institutional repositories. It really looks at how to handle the increasing data volume, since a lot of research projects now actually store their data. It looks at how different data types can better be managed, how support can be set up for different types of data. It really tries to facilitate with data publication, so to make this a real and valued part of research, and in helping to share data. It fosters multidisciplinary collaboration by connecting disciplines that now work separately. And it does that by making sure that data is fair, and that also the providers and the services can work with this fair data. So it really tries to create an internet of fair data. So this is a quote from the European Commission. It really tries to gather all the European researchers and the professionals in the scientific field and create a virtual environment to free at the point of use open and seamless services for storage, managing, analyzing, and reuse of research data across borders and scientific disciplines. So this is really the aim of the European Science Cloud. This is how it looks visualized. So maybe I can give an example of what it would mean. I'm not a researcher myself, but let's say that you try to see if climate change had an impact on how fish migrate. I can imagine that for this you need a lot of data, climate data, weather data, ocean temperature data, and the movement of the fish data. So you will look for data repositories in different fields and disciplines. So you need this interoperability layer to make sure that these different data sets, that you can find them and that you can combine them, that you have software to open this kind of data and process this data, in services that can help you with. Maybe you need a lot of computing power, so this is on the IT side. And maybe it would be nice to visualize some of your data and to store it while you work on this data, and of course, after you work on this data. And then there are the users, which are important. It not only scientists, but also society can make use of this whole set of services. And it really is the aim to integrate all these possibilities in one what is called European Open Science Cloud. So FAIR is a crucial aspect. That's also why this research data management mandate is in place, because it makes sure that this can work, that data can work with each other. And also it's very important not only for the data, but also for the infrastructures and the services, that they are fair as well. But let's go to a practical implementation of this European Open Science Cloud. What can you do with it? So all these services and infrastructures are brought together in one place, and this is called the Marketplace. So if you go to the Marketplace on the EOS portal, you can actually consult these services. So there are services for data and data processing, for data storage. There's cloud computing, for example, for genome analysis. There are workflows that you can use. Training and support is an important one, because scientific, if you ask for scientific data management, there should be some support in place. High performance computing. So it really is this package and place where researchers can go to if they have a question relating to data management, and this really can be everything. This is the mission statement. So the idea is to boost European research by providing all necessary interfaces and functionalities to equip EOS users with knowledge about and possibilities to use the researchers available in EOS for the sake of supporting science across Europe and beyond. There's a lot of functionalities. At the moment, I checked last week, there are 284 categorized and described resources. They're both generic and discipline specific, so there can be thematic services or generic. It really goes over all branches of science, and there are some resources also for tailored specific use cases. So if you have a question, you don't know where to start, you can go to EOS and actually ask if they can look at your use case. There are 4 types of access mode. I will talk about that later. And at the moment, there are something like 160 different providers in different communities that provide researchers. You can communicate directly with these providers and ask about their researchers. There's a lot of attention given in EOS to provide feedback, whether this is to the providers or to EOS themselves. And a lot of support. So the idea is really that it's something that researchers can use, but also that they have a say in what comes next and what works well and what doesn't. So I think I'm going to do the demo with my slides, just to save a bit on time. So this is the link. Slides will be made available after the presentation. So you can go by scientific domain. So this is the first thing that you see if you go to the marketplace. There are 9 scientific domains to start with. So if you're looking for something domain specific, this is probably the best way to start. Let's look at the example of natural science. If you click that, you get all the resources that are available. And this might be a bit overwhelming. So you can specify further what kind of categories you're looking for. And the categories are those. So you have access to physical or e-infrastructures, aggregators and integrators. You have processing for processing data, security for anonymization, for example. You have sharing and discovery. For example, if you want to write a data management plan or if you're looking for a data set. And then training and support. So look at sharing and discovery. Again, here you have a list of all the resources that have to do with sharing and discovery. And from there on, again, you can specify what you're looking for exactly. So you can discover all these functionalities when you click on one of the resources. On the right, you see the example of cloud computing, for example. It will give you a detailed description of what this resource is about, what it can do to you, for you, and it gives you some details, technical. If you click on details, it will give you some technical specification, reviews if people gave a review, and then resource offers. Again, I will talk about this in a moment, but there are different. Some of the resources are openly available for others, and others are you have to fill out some information. So the marketplace has been updated, and so they have a bit of a new layout. So you can take the guide, and it will explain this new layout, explain what the classification means, and the about section, how it works. So when you're looking for one of the resources, what is very handy is that you can actually filter. So you can filter on categories, or you can filter on scientific domains, and you can also compare different resources. For example, if you're looking for cloud computing, there will be more than one services. And if you click, I hope you can see my arrow here, add to comparison, it will actually give you an overview of all the resources that you want to compare, and it will give you the difference. So you really have an overview and can choose the one best suited for your resource. You can make a user profile, and this is really interesting and handy if you want to have a quick overview of what kind of resources that you use. So you can save them to your profile, and you get notifications if you want to on updates about your resources. But you can also add your own categories and interests. So coming soon to the profile will be a personalization. So you will be able to personalize your portal, as so to speak. And so then the EOS will also give you recommendations when browsing resources. So it's really tailored to your project. Another way to tailor this EOS Marketplace is to add a project. And here you can organize your EOS resources in a manner that suits you best. You can collect the resources for your case. So for example, your data management plan tool and your repository and your cloud computing. And you can monitor the order status of your EOS resource. And you can interact there with the providers and get more support. So I talked about the ordering. So not all resources are by definition free. So there are different types of resources. And there are 5 types. So the first one is you have to make an order. And this means that you can access the resource after a procedure. And this can mean that you have to pay for it, but it also can mean that you have to specify what your project is about or who you are. Then you have open access resources, and this is open to everybody. So there's no procedure, but you have to have an authentication. Then you have fully open access, where you do not even need to log in. So you can use the resource automatically and direct. You have other, these are unclassified mostly resources, and then you have various other types depending on the resource offer selections. So these are a bit different types in how you can access these resources. So the main page of the resource will also tell you what kind of access is of relevance to this resource. You can choose there to choose the offer that is appropriate for your use case, and depending on the order type of the resource, next steps will be indicated. So it can be that you can go directly to the resources, or you have to fill out some information, or you have to make a payment. So you can find all this information once that you have made a request in your profile, in your order history, and it will also give you updates on how it goes with your order. If you have some questions, there are different layers of how you can ask questions. So if you have a question about the resource itself, you can contact the provider of the resource directly and ask by selecting the resource. And this is about really if you have any difficulties or questions about technological aspects of the research itself. On the other hand, if you have a question about your project, you can also contact project support. Other support channels, so as I said before, it really tries to be as user-friendly as possible. You can also ask a question about a specific resource for authentication. So it's open for everybody to ask a question about the resource, so that you can, before you order anything or before you look into it, can already have your questions answered by the resource, and it's carried out over email then. For technical issues with the EOS portal itself, there is a report button, if you have any issues with technical issues, and this is really about EOS Cloud itself. And there's also a feedback mechanism. You can use, you can rate the resource that you use. So you can only rate if you use the resource, and it's really used to measure the quality of the service delivered by the provider. If you have a general feedback about the EOS portal, there is also a questionnaire feedback mechanism for that. And you can do any suggestion for the EOS portal in terms of development, in procedures, and really the idea is that researchers can create the portal together with the European Open Source of European Open Science Cloud. Wow. And so there are really a lot of ways to provide feedback and make this portal really useful for researchers themselves. So this is, in short, the European Open Science Cloud, and also the end of my presentation. I would say give it a try, and it's always easier to comprehend such things if you look into that. So I think I will now give the floor to Ellie. Let's stop sharing. Unless we do questions now.
I think we can continue, and then yes, we'll have questions later, or even the Slido.
Okay.
Thanks, Emily. All right, so just a few things to add on Emily's presentation, which was very, very nice, and thank you very much for thoroughly explaining to us and making those links between the first day, what we said and mentioned on the first day, and also how data are important in this growing ecosystem, which is fair enabling and open science enabling. Emily talked about data mainly, but she also mentioned that that the European Commission supports the implementation of open science by and through the EOS, the European Open Science Cloud. So this is one way that they support the implementation of open science. And the whole EOS, let's say, it's built on with core principles, having as core principles the FAIR principles, so that the services and the infrastructures are integrating the different best practices and allow for data to flow easily around and to be described and interoperable between them across domains and across different systems and so on. So why having just a service? And this is for the more, let's say, for projects that have to deal with developing services, that services has as input or as output data most of the time. So this is why it's important to also have some provisions about data management when we are developing, in the phase of developing the service. We saw that why this is important, because we are moving towards fair enabling access to apply FAIR principles beyond the data, because you understand that we have to describe with specific metadata standards the data. We have to apply persistent identifiers for the data to be findable. So all these kind of elements not only lie on the responsibility of researchers and how they are responsible and they will take care of doing that for their data, but also that lies on the provider's side, on the service that supports those and holds the data throughout the whole research data management life cycle. So that this is important to have another view of how the FAIR data can be, of how the FAIR principles can be applied in services or repositories, so they can, so at the end, the researchers can have FAIR data. The concept of digital objects is a concept that clearly shows how you can get a value out of the FAIR data. And here you can see when, for example, when we start from here, when we produce data without having applied any of the FAIR principles, then we just, our data are basically useless, reuseless. Maybe others cannot reuse them. We can only reuse them because we can have, we are the right holders, let's say also. So others do not know how to reuse them. And we mentioned that reusability and reproducibility is a big part of open science. Then we see that moving on, if we have our data as before, but just attach a PID, persistent identifier, they quickly, immediately become findable. So then we let's say, satisfy the findability of the FAIR data. If we attach more things, if we describe our data with some metadata, so like who is the author, where we can find these resources, which instrument maybe has been used to extract these resources from, and so on. So if we have some metadata that allow for people to interpret and understand our data, and we keep the provenance of the data, show how we come up, how we came up to the data that the researchers have on their laptop, then we have FAIR metadata. Then if we move on to providing some data elements on the restricted access, then we have FAIR data and restricted access. If we provide the data on open access, then we have FAIR data in open access. And if we provide everything in open access, we have our FAIR data and open access functionality linked. So we also make links with the different, the data, the PIDs and the metadata that they correspond to. FAIR software is a good thing to know and to consider when developing a service because it allows for software to be archived, provides metadata and vocabularies to our software, so licenses so it's reusable, and identifiers so it's findable from others. And you can do that throughout the whole granularity levels that you see here. This is how you can apply the FAIR principles for software. And an example why a service is not enough without having, let's say, applied open and FAIR principles. I take as example the repositories, right? Because this is the most common, let's say, that we see the research performing organizations and are developing. So having a repository, it's not enough because it's not, you know that you can access it if you go to the website, but then what? If you don't know the URL, or if you don't know that this repository exists, what do you do? This is why you have to register the repository on some broader, let's say, providers and registries, they're called. Open Door or Rethink Data, we'll see in a minute. The repositories have to have clear policies for how we allow people to use our content, either people or machines actually, for text and data mining. Metadata should be clearly described and provided in maybe open access so that we satisfy the interoperability element. Licenses should be given and should be clearly described how licenses and what licenses apply to the repository itself, to the metadata that the repository provides, and to the content that the repository provides. So licenses for all those three elements. A certification might apply to repositories. There are different certifications for services. For repositories, for example, a very common one is the Core Trust Seal. And we'll see in a minute what this means, so that we ensure that our repository is trustworthy. And there are some FAIR metrics that we could apply to our services and to our repository so that we see how well we have provisioned for a fairness of data and when someone uses our service. All right, so for the registries, you can use this. There are these three core and key registries that you can index your own repository. The open door, open directory of open access repository, the read-through data, which this for open access repositories is for literature only, not data. For data, it's the read-through data, which you can submit your resource on read-through data. And then for EOS also we have the OpenAir provide. It's linked directly to EOS, and it can be used to Gültekin, I think will show how you can register something in provide. We also saw that yesterday. Metadata, what metadata should the repository, what policies, sorry, should the repository have? It's about metadata. What metadata it provides, if it provides it free of charge, it's very important for researchers to find those kind of information in the policies of the services that they want in order to comply with the FAIR principles and to write those things, to write them down in the data management planning. For example, this is a very common question that you will find in the data management planning if the metadata are provided free of charge. So the policies should also include those kind of issues. Then there's a data policy. How are the data handled, and what are the different things that are the different criteria for data, content policies, for how others can acquire and the data, the acquisition policies, and so on. Submission policies, what authors can do to submit, if there's a self-archiving, for example, for data, and preservation policy, very important to satisfy the preservation aspect of open access. Another thing is the repositories interoperability, and you can do that by implementing, for repositories in particular, you can do that by following the guidelines of OpenAir that we saw yesterday. Also, they were mentioned, and these, if you follow those guidelines, you comply also with the European Commission mandate, because we have all the different aspects that need to be applied from the researchers in order to comply, be satisfied. For example, we have in the metadata, you will find the acknowledgement of the funder, you will find what access conditions apply to the content, and so on. So if the repositories have these guidelines, it's even better, let's say, and closer to compatibility and compliance with European mandates. And you can do that by, you can validate those metadata once you have correctly a list of metadata that you want to provide through OpenAir. Then you can validate them and see what you can change in the metadata. Maybe some field is missing, maybe something you need to tweak in order to be compatible. So you can check the validator and do that and increase, let's say, the level of compliance and visibility of your research, because this is why it's all happening at the end, because research becomes more visible if things are interoperable. Sorry. Then I mentioned certification and trustworthiness of services and repositories. And one way you can start from is from the core trust seal. There's here you will find a list of different, as you can see here, of different processes that you can start looking at this list and checking what you need to have in order for your repository or your service to be certified in terms of trustworthiness for other people to know how to use it. And another thing I mentioned is the fairness of data, and you can use those different things. There's a tool that you can use to assess the fairness of data. That Fuji, some people integrate those kind of methods and of tools maybe to their services, because they want to show also and support researchers understand how fair their data are. So they also integrate those kind of methods for fairness, for fair metrics in their systems, in their services. Things to consider overall is what type of service it is, in which step of the research data management lifecycle is this service that you are developing. So maybe it's not only under one step, but in more of them. What are the basic service components that it has? Where does the service act on the digital object? As we saw, is it at the bit stream? Is it at the metadata, at the PIDs? Where is this service? Where does the service act? And get started with the certification. That's a suggestion that I could make, just to check the operational aspects required and guide you through what's needed also in terms of policies. And thank you very much.
Thank you, Ellie. I was happy also to see that the number of attendees has increased, but I also saw a message from Kemal that there were some problems. So there are people who are watching it on YouTube. And I see that there are no questions, but if there are any questions from the people from our audience, please provide us with, or as Ellie especially will be in the next presentations with us, you can also with some delay ask questions. Many thanks to both of you. And I don't know also if Emily, you would like that Kemal will again show the Slido questions so that we might get some more answers, or to proceed to the next session as planned in the agenda. Emily, would you like that we give it a second go, the Slido questions?
I think seeing the time, that maybe it's a good idea to go to the next session. If there's no questions from participants.
Okay, so then please, let's proceed to the next session. And many thanks. Actually, we were only 1 minute late with the first session. So this is a very good thing, that we will not be running out of time. So please, now it is Ellie and Gültekin.
Yes, okay, let me share my screen again, but for a different presentation. So in this session, we are going to see more practical things, and we want you also to take part on this so that you get more familiar, let's say, with what's out there and how you can search and how you can use some tools that are out there. So that's why we created this presentation, which you can take it and use it in your everyday work as a handbook, actually, if you see it. This was the approach that we started creating this resource, so that it can be used later by you, not only for this presentation. So I won't go through this slide. You already Emily very thoroughly mentioned different steps in the life cycle of the different activities that are under each one of the steps. So here we can see some of those under some activities that are under those steps, and what are some key resources that you need to. It's good if you know, and in order to plan accordingly your activities and add them in your data management plan, and then follow them to implement the open and fair principles. So starting from planning, as I mentioned, this is a tool for costing your research data management activities, and it's good if you do that at the stage of planning your research. Write down exactly what are the kind of activities, the data that you will produce or you will collect or reuse, and what are the different methods that have to be applied on the data. For example, will the data need to be transported to different formats? Because this takes time to do it, and it might require some resources, not only PMs, not only people's effort, but also it might require for technical resources to be acquired for you to proceed with some of your activities. Maybe you need to acquire data storage, which can have costs, and so other things. So this is a very good infographic which goes through the different, let's say, as you can see here, the different stages of the research data management lifecycle, and has some examples of how you can allocate resources across these different steps, and what you need to take into account. Again, human effort and technical service acquisitions, maybe. A good tip to know is that it's very good that TÜBİTAK is already has already provisioned that. It's infrastructures. You like Aperta, for example, those kind of infrastructures, like at the national level or infrastructures at the institutional level, reduce amount of money, of costs that you are required for research data management activities. So this is very good to know. Things to ask is while you're costing your research data management activities, if you are working for a data intensive project, is if you will need a data manager, a dedicated person, in order to manage all your data. Or if you will take also, let's say, hire other people that might require less, has minimum salary, let's say, like students, to minimize your costs. And another thing to ask, is there any national institutional infrastructure available to limit costs? And this is why you can talk to your libraries, you can talk to the funders and see what's out there in order to do that. Here I have an exercise, a small exercise that I would really like you to go to the EOS Marketplace. Emily showed how this works, and I would like you to find a resource about data storage and a report back if this, where you can find the costs, the pricing of this resource on the EOS portal. So if you could just go, and I can do that with you. You have to reshare my screen. Okay. If you can go to the EOS, and maybe someone can help me to write on the chat. Maybe I can do it. To write here the EOS portal. EOS Marketplace, all right. So I will paste this link here in the chat so that you see. If you can go here and find a resource for data storage, and please write in the chat, write in the chat. Let me just open the chat again. Report the first data storage service that you find in on the catalog, the first one. Click and find the pricing, how it's cost. And please put the link in the chat. Let's give one more minute for people.
Also, we have a question in the question and answer. Maybe you can answer this question, Elif.
Yes, maybe one. Okay. Is there a service within EOS like a motor which automatically turns the raw data into a uniform interoperable shape depending on the type of data and theme of research? If possible, could you navigate through EOS code to show how to do it? Oh, okay, all right. Yes, we could do that. Or maybe Emily, do you want to do it? Maybe, or I can do it. I don't have.
Yeah, go ahead.
Okay, so. All right, so I will close this. All right, so I'm not aware of all the resources that are available in the EOS Marketplace. So let's see. We can go to here. Oops, sorry. We can go to here and find the type of service that we are searching for. Like, for example, this would be a processing, maybe. Turns raw data into a uniform interoperable shape. So something that has to do with processing, because it takes the raw data and process them to make them. And what was? Oh, sorry, I left the chat. So what was motor? What do you mean by motor? If you could just write down the discipline or something more, let's say, like a keyword, what we could use in this search.
Search engine, I guess. I assume that the search engine talking about like a motor.
Okay. Is there a service? So, okay, what's the data? No, I don't think there is, but okay, so processing. So we need a service to process our data from raw to something else. Okay, let's just do this, proceed with this. Find all the resources that are under processing and analysis of data. We see here that we find many, let me minimize this. We see here that we find many resources, right? You see access to resources for specific disciplines, chipster and so on. So maybe if this kind of, do we have another one? Let's say we do a survey with immigrants and got survey results in interoperable format. Okay, so I think, yes, it's the same participant. Okay, let's say we do a survey with immigrants and got survey results. How do we turn this into an interoperable format? Okay, so here you see how you can find the different processing tools, right? And for example, a survey would be under scientific domain, humanities, maybe, I guess. And then here we can see all the processing and analysis tools for humanities that we can check and find the one that satisfies this particular need from the question, from the Q&A, right? And for this question, but how do we turn it into an interoperable format? You just take the survey, you process it as you would normally do, and the results on the CSV file, for example, from this survey, if it's going to be a questionnaire, I don't know what kind of method will be used, but I assume that it will be something that you can find on a CSV or an Excel. Then this CSV you can deposit on a repository that has applied open and fair principles. So you can check in the uploading. We'll see how an upload can be done in a minute. So while you upload it, you can check the metadata and see and describe it. And that way, if the repository, again, is following the fair principles and is a trustworthy repository, and it's part of OpenAir especially, it will provide, let's say, the metadata in an interoperable format, the metadata. I hope this was clear, but please ask more things in the Q&A. So I think we have to move on. We have to move on. Stop share and then share again. Session 3. All right. So we saw about the different tools, right? Then in the planning stage, again, after we have cost everything and we have found the research and we know how to pay, or if we don't have to pay, actually, that's even better. We have to describe everything in the data management plan. And this is the session 4. We'll talk about Argos, but I added it here because it's good to have for later and use it as a handbook, as I mentioned. And then this is up to you, Gültekin.
Okay, thank you, Ali. Good morning to everyone. I thank you, every one of you, for being with us today. We are going to cover lots of things today, and then I would like to show you how can you find the project and research data, other research output with your project. I will share my screen. Let me share my screen. Ellie, stop your sharing, please. Okay. Yes. So I'm going to, if you click on the link, explore OpenAI.
Is it only me that I don't? Gültekin, we cannot hear you.
Okay, excuse me. Thank you, Ellie. Good morning to everyone. We will cover lots of things today. It will be a very busy day, and then we are going to share lots of things about data and open data. Now I'm going to show you how you can find a project in OpenAI and how you can find dataset and other research output with the project. When you came to the explorer.openair.eu website, you can see different filter in here. If you choose one of them is projects, you can write down your project with me if you would like to try with me. I'm going to use OpenAI for example, and then click on the button, search button, and it show me the project as a keyword within the OpenAI, and then I will choose one of them. I will choose the OpenAI Connect project. The system show me that the information about the project, also show me that the related research output with the project, publications, research data, software, other research output. If I click on the publication, you can see the all related publication published related to this project. If you click on the research data, it show you research data related to this project. When you click on the DOI number, it takes you to the Zenado. Zenado, you know that the repository for the OpenAI. When you came to the Zenado website, you can see the project research data set as a CSV. Also, I would like to explain the question asked before. If you would like to make your data interoperable, you can choose the right format. For example, if the researcher share their data as a PDF format, it's not interoperable, not reusable. but this researcher shared this data as a CSV, so it's interoperable and it is reusable. This is the main differences, the formats of the research data. Also, this page will show you usage statistics, how many times your data viewed, how many times your data download. Also, all necessary and related information about your data, DOI number, keywords, and other grant information. So if you get back to the page and you would like to link any data or other research output, just click on the link this project and then describe your output, and then the system indexed your output in here. So it's you can take the screen again, Eri, we can continue.
Yes, okay. So this is why it's good if you have any project that Horizon 2020 project to go and follow Gültekin's path and find your how many outputs you have under your project. And this is how you also report it. You can download this CSV file with all the outputs and report to the Commission. So, okay, moving on to the next. We have, let's share my screen again, so we see how we do that. And we have a tool for finding metadata standards. Metadata are a big part of data, of how we describe data, and they can have multiple, let's say, levels. They can be descriptive, so very the minimum, let's say, metadata that someone needs to understand our data, but they also can be more technical, so they might describe the methods and the different tools used and so on. So we'll need to find the research community metadata standard that we can use in order to be to follow the FAIR principles. Also, this has to do with the FAIR principles of data. And if I go to this resource that I'm also having here, sorry, I can see the panel also, and I do not see what I have open. Maybe I can open it again. All right. This is the metadata catalog, which you can browse and select, like browse, for example, by subject. You are working on which discipline? Let's say that you are working for biology, and you want to find a metadata standard that is for this particular community, for this domain. Here you can see the results are 3. This is the minimum information for biological and biomedical investigations. It has a description. It shows us what fields it has, like 40 checklists of minimum information for various biological, so on. This was who developed it and how you can use it. Observe OM, similar, who developed it and how you can use it. PD, BX, MMF for protein bank data exchange. Dictionary, let's say that we want this because this is closer to our needs. We can go to this to show its documentation, right? And find other relevant information like who has used it, like which service is using it, which tools are there to support it, and so on. So if I go to the documentation of this metadata standard, I can check what fields are needed, and I can see how to use it to describe my data according to this standard. Okay, so that is that. And maybe I can share this. Do you see my PPT, the slides now?
Yes.
You see the slides? Okay,
Yeah.
okay, perfect, perfect. So now Gültekin is going to show the R3 data and the data registry that we mentioned today.
Please stop your sharing, Ellen.
Yes, yes.
Okay. So you know this your standards of your metadata, but you need a data repository. What you are going to do, you have to find the data repository for yourself. R3 data.org really helps you to find a repository. If you want thematic data repository, for example, you are a researcher field of the archaeology, just click on the keywords to here and then search. The system shows you thematic repositories related to archaeology. Also, you can use the browse features. It's browse features, for example, browse by subject. It's a very, very nice interface they have. For example, if you choose the chemistry, and then analytical chemistry. If you click on the analytical chemistry, the system shows you all the thematic repositories related to chemistry. If you would like to choose by country, for example, it shows you all the data repositories around the world. Green ones have a data repository, but the blue ones didn't have any data repository. For example, if I click on the Turkey, it shows you data repositories, Aperta in here. Aperta is also a registers repository, first registers repository in OpenAIRE 2. So R3 data will help to find your data repository. Okay, I stop sharing. We can continue.
Okay, did you see the metadata resource that I was showing before? Because there is a participant that couldn't see the metadata screen. Did everyone see it, or should I quickly go through it again?
Maybe we can repeat it.
Maybe very, very quickly, just so, okay. Share screen. This is the screen. So I hope you can see my browser now, right?
Yeah, it's working now. Very well.
Okay. Thank you. I didn't notice. I apologize for that. So if you can go to this catalog and browse by subject, right here, you click here, and a whole tree of different disciplines appear and sub-disciplines. I clicked biology before when I was showing to you this. These are the results for metadata standards that exist in biology. They are 3 here. So I click one that seems to satisfy my needs. Let's say that's the one. I can see different topics, different areas that is used, biology, chemistry also, it can be used in chemistry, crystallography, and so on. I can see the specification, right? I didn't want that. I can see the specification, I can see who is responsible, what other services are using it. So I know that they are compatible with this standard. So maybe I can also use those services if I need to. And here I can see the documentation. Do you see the documentation? The dictionary index. This is how you find metadata standard. All right. We'll now continue to the next. And the next is about archiving data and software in Zenodo. And it's very easy to do. And we'll show very quickly how this is done. Share dictionary. Okay, so if we go here, we go to Zenodo. Do you see Zenodo on my screen?
Yeah, Zenodo. Yeah.
Perfect, perfect. Okay, so there are two things that I can do with Zenodo, as already mentioned yesterday by Irina and by also Dulfikin, I think, and Emily. So either you use Zenodo to upload your resource, your data, your publications, your poster, or whatever this material would be, or you create a community. And I want to show this because we see that many projects, Horizon 2020 projects, like for example, EOS Pillar, EOS Europe, and other OpenAir and so on, different projects create communities inside Zenodo. So they hold all the deliverables, the posters, the dissemination materials, they hold them there. And they show, let's say, to reviewers also, that's good for reviewers, to show that although it's not mandated to have all this material open access and fair, we do it because we want to promote that through our project. So even though the deliverables, as we saw yesterday, it's not a mandatory thing to have in open access, you still can get credits for doing that. You can create your community very quickly. And this is essentially a community. Zenodo is like a collection of outputs under a title, under a specific heading, a title. So for example, I can create a new community like this. I can specify the identifier like community for OpenAir, the title that it can have, project name. Here we can have the project name, a description of what this project outputs will be, and fill in some different, let's say, curation policy if we have in place and so on. Upload a logo and then click create, and it's that simple. It's a very simple process. Otherwise, if we do not want to use the communities, we can use Zenodo to upload to upload our resources on Zenodo, right? If we don't have any other repository, because this is a generic repository, and we saw from Emily's presentation that for data, especially, it's good to prefer thematic data repositories. But if there is none to satisfy our needs, we can click new upload, go to Zenodo, sign in, click new upload, and upload our data, right? And check the type of the data that we want to describe. This is, let's say that we're uploading data. There are different things that you can have, that you can upload, but now we are in data. You can reserve a DOI for this data. So click reserve DOI so that the system that is provided by, that is integrated in Zenodo, the DOI system can assign you a DOI. DOI really help to persistently provide access, and so that you will be able to find, let's say, your resource, even if your resource is moved to a different URL, you will still be able by the DOI to find it. You know, very basic metadata, publication date, title. So you fill all those in, and you click. Oh, no, it's very important to show why this is compliant with also the European mandate, because it has a specific section about license, how you want, what license you want to use, right, for your for this resource, and also you can acknowledge the funding by typing, let's say, finding your project here. Let's say that I'm looking for OpenAir. This is the project that I want to acknowledge. This is the grant ID, the funding number, and by doing that, I make sure that I acknowledge the funding, which is a requirement. Right. So that was it for that. I will now go back to the presentation. I will go back to the presentation, and we are going to see, Gültekin is going to show us a tool to decide which license to choose. If we don't know which license we want to choose, then it's, so maybe sometimes funders are giving us which license they want us to use, but in some cases it's up to us, a range of different licenses to choose from. So this is a good resource to know of.
Where is it? Yeah. Do you see my screen?
Now, no. Before we could see something, a white screen.
Now?
Yes, yes, perfect.
Okay. Your metadata is okay. You find the repository, your data is okay, but you would like to know how to share your data. You need a license. You choose a license for your data. You have two options. One of them is the Creative Commons licenses. You came to this website. The website is asking you questions. If you answer that questions, it shows you the Creative Commons license to deposit your deposit your data, and then it will show the people how they can use your data. For example, do you know which license do you need? If you know, you can click on this. Different types of Creative Commons licenses here. If you have any information about that, you can choose one of them. And then it shows you different fields. If you fill the fields, for example, I filled this field, title of the work TÜBİTAK, creator of the work Gültekin, and then year of the creation 2020. If you look at this right side of the screen, you can see the Creative Commons license. If you copy of this and then put the link to your data, you can explain to the people how you allow the people to use your data. Other one is if you would like to take the HTML code for your website, you can copy of the HTML codes and then put your website, and then you can share. If you don't know how to use, if you don't know how to choose your license, you need help. Another option you can choose. Next, confirm that the Creative Commons license is appropriate, and then you can click on all these things and click on the link. No. Yes, it's working now. After that, this question is really important. Do you want the attribution for your work? If you say yes, anyone using my work must include proper attribution. Next one, another question is coming. Do you want to allow the others to use your work commercially? If you would like to allow the people to use your work as a commercially or no commercially, yes, other can use. Next. And then do you want to allow the others to remix or adapt or build upon your work? If you choose the no, it shows you same field with the license. You fill the fields. After that, it can show you same license for you. You can copy or you can take the HTML code and then you can put your data website. Okay, Ellie?
Yes, I was also trying to type to answer a question. but maybe I can do it live. There's a question about, do you recommend to deposit to thematic repositories or directly to a service within EOS or both? So what I was typing and I didn't finish is that EOS is not mandatory to use, but it is very possible that it will give you more credits in the review because you have used it. That depends, of course, on the reviewer, right? But for repositories in particular, their metadata are currently offered by Opener Explore in EOS. So if the repository follows the Opener guidelines and its metadata are validated from the validator, then let's say it's both. It can be both a thematic one that is Opener compliant and being at the EOS. So you can have both, let's say, ticks under this this question. But it's not mandatory. You should feel free to deposit on repositories, but please make sure that the repositories are compliant with open and fair principles. That's what you have to have in mind. Okay, great. Then, moving on, we've included here another resource. Okay, we've included here, sorry, another resource. So this is what Gültekin was showing to us. And this is another resource that we don't have the time to go through now, but you can do it in your own time. And you can always feel free to contact us for any questions that you have throughout this, this two-day event. This is a license clearance tool. It helps you to see how you can reuse a software, for example, data, if you want to remix it, to produce derivative works out of it. So you take data and you have your data and you want to combine them. What licenses are compatible for this kind of processes? This is what this license clearance tool helps you to understand how to license derivative works. Anonymization, we'll talk about that in the next session. We have Manolis with us, who is head of development, and he's going to demonstrate and explain to us very key concepts that we need to know about anonymization, and explain us and demonstrate how this tool can be used. And a fair assessment tool that is very good to have also for researchers to know and to use is the fair self-assessment tool by ARDC, and I'm going to quickly demonstrate how this looks like. New share. Sorry, let me also, maybe I can open it like this. New share. Okay. I am in the assessment tool, right? And I'm not sure I have applied, perfect. I have applied some of the things that I listened to this throughout this two-day event, and I'm not entirely sure though how fair are my data at the end. What you can do is go here and answer to these questions and get an indication of how fair your data are. Like, does the dataset have any identifiers assigned? Let's say that I have assigned identifiers to my dataset through a DOI system. We see that this bar will start to grow according to how fair, how fair our data are, and here according to how findable they are, because we are under the section findability. So for, let's say that we have used DOIs to describe our metadata. Is the dataset, next question, is the dataset identifier included in all metadata records files describing metadata? Yes, no, let's say yes. How is the data described with metadata? We have a list of things like, how is the data described with metadata? Are they using a recognized formal machine readable metadata schema, or the schemas that we see before, you remember? Or is it a non-standard format? This is why we should prefer standard formats for the metadata, and we should use this dictionary, the metadata standards catalog. Let's say that we didn't use it. We couldn't find anything. We didn't provide metadata, describe metadata in a standard format. And what type of repository or registry is the metadata record in? Let's say that it's in a domain-specific repository. So quickly here I see that for findability, I am like, let's say 80%, 83%, I don't know, 85 maybe percent. My fare are findable for 80%. Accessible, similarly, I have to answer all these different questions, and I get, so I will randomly do that, and I get a percentage here. For interoperability, I have to answer these questions, and I get, again, for interoperability, a different, let's say I get this percentage for interoperability, and for reusability, let's say that I will use a Creative Commons, and this is my percentage for reusability. At the end, what I have is the total fair assessment of my data practices, how my data will be, how fair my data will be, and I can go back and work on different areas if I want to strengthen them, and so on, so that I increase this a little bit, right? All right, so then we move on to the next, which has to do with repositories and services. So the first resources were for resources. Now we're talking about repositories and services. We said in previous presentations that having persistent identifiers is very important for FAIR, for findability in particular, and I explained before why this is important, because even if you change the location of the URL where the data are, you are still through the persistent identifier, you are still able to find them. That's why they are persistent. They're called persistent identifier. And you can have systems that you can find systems that you can integrate in your own services for PIDs for digital objects, so that you provide a persistent location, let's say, for your identification, let's say, for your digital object. And DOI is very popular for data, for example, and for publications and all digital objects, actually. HandleNet registry is a different provider, different system, but it also has a standard format that it's used to produce PIDs when you use it. ARC is a different PID system, and so on. There are different PID systems for digital objects. For researchers, we saw, I think yesterday, Argyro mentioned about ORCID. The ORCID ID, it's a persistent identifier for individual researchers, so that all our research outputs and the intellectual works that we have are identified permanently through this unique ID, this unique number that we are given if we sign into ORCID. And we can integrate those two systems like we did in OpenAir, and you can create links through this with DOIs and so on. So you can play around by integrating those different PID systems in your services. And funder registry also, there is the Crossref funder registry where you can which you can use for persistently identifying the organizations. And this is a very growing, PID systems are growing into including more activities. And also very recently, the past week, we have a PID for DMPs, data management plans. So we might find more PID systems for other activities like research projects. So you can see here if you are eager, let's say, to explore the EOS the EOS Marketplace, the EOS portal, and provide your resource through the EOS. You can check also this EOS AAI to integrate the authentication and authorization infrastructure. And also check the different things that need to be in place for you to be compatible, because you might at the end want to not only have this service that you're developing for your institution, for example, but also provide it through the EOS Marketplace because it will gain more visibility, let's say, from there. Yes, and now I have to give the floor to begin. Begin?
Stop your sharing.
Okay.
Okay. Yes, as I mentioned before, we will cover lots of things today, and then if you need much more information, we have guidelines in OpenAIRE. The OpenAIRE guidelines helps the repository manager expose publication, data set, and increase metadata via OIA PMH protocol. PMH protocol is very important for the open science. It's a standard of the open access in order to integrate with the OpenAIRE infrastructure. So as I mentioned, we have lots of guidelines. For example, I would like to show you OpenAIRE guidelines for the data archives. If you click on the links, you will see all the elements of the guidelines for the data archives. For example, if you would like to get much information about the identifiers, just only click on this here. It shows you all the information or related information about the identifiers. If you get back, if you need much more information about the contributors, for example, contributors fields, you can have lots of information, all necessary information about the contribution field. So OpenAIRE guidelines always with you, anytime you can use. If you have any questions, you can send your question to the OpenAIRE ticketing desk. Okay, Elif, I'm stopping my share.
No, I think it's also you now.
Yes, you're right. It's my turn. I can continue. Yes. Also, I would like to show you I would like to show you how you are going to validate and register your repository to OpenAIRE. It's also important features. When you came to the provide OpenAIRE.eu website, you can click on the OpenAIRE password. You will see this screen. But I would like to highlight one of the important things. If you would like to register your data repository or another repository or journal, for example, for the data repository, you have to register your data repository before OpenAIRE to the read3 data when you click on the link, it shows you, please make sure your repository registered in resource data. So you have to register your data repository before registration of OpenAIRE to the read3 data repository. After your registration, it's another features in here for validation features. You can use the validation features to validate your metadata of your data repository. If something is missing or something is wrong, it shows you which metadata have a problem, and then you can correct, and then you can validate again. Okay, Eli.
Okay, I think we have finished this session with practical tools to use if you are a researcher that you want to apply some good practices, or if you are developing, if you're a researcher developing a service, also what to do. Any questions maybe now, or Adamantios, how would you like us to proceed?
First of all, many thanks. What I had in mind yesterday was that in case we could change the agenda to have something like a round table discussion, where we might collect some questions from the audience, which means that now I see we are 10 minutes earlier. We may also sacrifice the coffee break. Yes. So that because everyone can, we all have closed screens, so we can go grab many coffees. The thing is that how would the panelists think about it? It might be, so as much time we can save, we might use it so that we could, all panelists of the first day and the second day could have an ad hoc round table where we may also revisit some of the questions of yesterday, okay? And also some comments that I was receiving in between privately. And I think that this would be a very good way to also close this event. So thank you. And let's go now to the second, to the fourth session of the whole event and the second session of today. And now it will be Manolis who will take over the floor, yeah? And Manolis, we are eager to hear you. And also, Manolis, you may be a very humble person, because I have asked all panelists to provide me some sort of information about their biographical sketch. And Manolis, you were very humble. So now you have to start your session and also present very briefly yourself. So you didn't avoid to do this. Yeah.
I'm sorry. Adamantios, thank you very much for organizing and this event and inviting me here. I'm Manolis Terovitis. I'm a researcher in Research Center Athena in Athens, Greece. I'm a computer scientist. I have a background in data management. And for many years, I have been working with privacy protection, and especially with data anonymization algorithms. My focus is mostly technical, but I'm also working as DPO in 2 large consortiums about precision medicine. And I am the creator of the Amnesia tool, which is a data anonymization tool that I'm going to present here. So I guess this should cover the introduction about who am I. So I should go and share my screen, and I should present now my work. Okay, I won't start from the end. So today I'm going to talk to you about data anonymization and the tool we have created, which is called Amnesia. I will have a demo later, and you can also, as I talk, download Amnesia. I used to have the link in the first page. You can download it and check it out, and we will also you will also have some time to do it in the demo. But in the beginning, I'm going to explain what data anonymization is and why it is important. I'm starting to from the GDPR, which affects the EU and EU citizens wherever in the world. But I think the basic regulations of GDPR are common in most privacy laws. So what I'm saying for GDPR holds for legislation, I think that the basic points all over the world. So the GDPR and similar legal frameworks put some tight bounds on the usage of personal data. So basically you can use the data only if there's some legal basis for using them, and or if you have the consent of a user. And only for the purpose that they are collected. GDPR has some flexibility to allow a company to use data for research. For example, if you're a hospital, you can use patient data to do research. But in general, the bounds are tight. You cannot share the data with third parties. You cannot use them for doing something that the users have not agreed. So if you're using the data based on consent, then consent is revocable. So anytime in the future, the users can say, I do not consent anymore, don't use my data, which can create significant problems. And also the users can refuse right away to provide you consent to use the data. And also, there are many safeguards about personal data, which responds to quite bureaucratic and complex internal procedures that, every decision to use a data set for a scientific purpose or any other purpose has to be checked by some internal committee, and you have to have procedures about anything. In general, GDPR protects the user privacy, but puts a significant overhead in how one can use the personal data. Now, on the other hand, we all know how important is personal data. I think they're actually the most important data, more important than sensor data from manufacturing or other sources of data. Data that describe human activities are very important. They're very important for research, whereas it is, for example, basic research in medicine or operational research, how a company allocates its resources to meet in not the optimal way the needs of their clients. And a key observation here is that, especially in research, we usually do not need the identifying information. For example, if you want to find some pattern, see some indicator, common characteristics of many patients with respect to a disease, you don't really need to know the names. You only need to know, for example, their behavior or some kind of measurement to their blood pressure or anything. So what we usually need for research is the non-personal part of the personal record. So this is the key idea in anonymizing the data, that in most cases we can use them as without knowing to which persons they belong. And also, when you deal with a large number of records for research, there is some tolerance in their accuracy. If you have many hundreds of thousands, millions of records, then a little noise on the data or on their aggregate statistics usually does not affect the research, or at least this is an assumption between many anonymization methods that needs to be tested in practice. So the idea is to use anonymization to free the data from the GDPR or other personal legislation or other legislation about personal data. By anonymizing the data, we transform the data from personal to statistical data. Now, I would like here to make a distinction that I'm going to use throughout the presentation, and it stems from the GDPR. There are two different terms in GDPR: anonymization and pseudo-anonymization. In everyday practice, we usually just use the most obvious term, anonymization. But GDPR makes this distinction based on whether it is possible to reverse the anonymization process. So when it refers to anonymization, it refers to a one-way data transformation where the original data can no longer be retrieved. You change the data in such a way that there is no algorithm, there is no way using third party or different data sets to go back to the original data. So this actually implies a guarantee that from the anonymizing data, the identities or other properties of the persons behind the data records will not be revealed. What Amnesia does and what I'm going to present here is anonymization in this sense, in creating a one-way transformation that provides a guarantee that the data transformation is not reversible and that the identities of the persons are will be secret, or at least there will be a statistical guarantee that they cannot be retrieved. On the other hand, we have pseudo-anonymization, which is the replacement of direct identifiers with an arbitrary number. For example, you might have medical records where you remove the names and you put a number there. So you give it to a third person and it's not obvious by just reading them. It is not obvious to which person they belong. But this kind of anonymization without any guarantee does not make the data statistical, does not prohibit. I think I have a cut here that I have to take down. It does not prohibit any third party, does not prohibit every third party from reversing the data transformation. For example, first of all, we might have kept a map between the arbitrary IDs and the names. So if somebody gets access to this mapping, it knows that number 14 responds to Manolis, and so the record with ID 14 is Manolis' record. Or it might use secondary information like the date of birth and the zip code, which can be identical, and the identity of the person can be revealed. So we will see here methods that we do this transformation and in a way that's no longer reversible. So to sum up, why one should anonymize the data? The basic idea for anonymizing the data is that we transform them to statistical data. They're no longer personal. The dangers that are related to personal data do no longer exist. The legislation limitations do no longer exist, and then they can be shared with third parties. They can be used for other purposes, and both the privacy of the user and the legal obligations that an entity has are safe. So till now, anonymization sounds like some kind of magic where we anonymize the data and suddenly the dangers are gone, our legal obligations are gone, and everything is perfect. Well, it is not that simple. The first and most obvious drawback of anonymization is that in the process of the one-way transformation, we use some information. The way to make the data be no longer identifying is to remove any unique combination of values in its record. Anything that can be used to uniquely or with very high probability lead to the identity of a person. So an anonymization algorithm has to balance two things. One is the strength of the privacy guarantee it will provide, and on the other hand is the information loss it will introduce in the data set. Now, GDPR, and in the first slides of my presentation, I presented anonymization and pseudo-anonymization as two clearly distinct things, and in maybe in theory they are. In practice, the things are not that clear. There are some gray areas. For example, you might guarantee that the identity of a person will not be revealed, and you can have a statistical guarantee on that. But on the other hand, a property might be attributable to a person, even if its identity is not revealed. So there is some gray area where the responsible for the personal data has to take the decision if this is safe anonymization or if it's pseudo-anonymization, if the strength of the privacy guarantee is enough, is strong enough. The criteria is if the decision has to be made by taking into account if important information about the natural persons behind the data can be revealed by some kind of processing. The methods I will describe here provide a strong guarantee, but there might be cases where the things are so specific or the danger is so high that that might not be enough. And also, as we will see from the process, it is how we apply the anonymization guarantee, that the anonymization algorithm, that is important. And another limitation is that the process cannot be fully automated. We do not have at this moment, it's a new process, enough experience, and I don't mean with amnesia, but with anonymization in general, there's no enough experience or common knowledge or common ground on how it is going to be applied. The regulations that help us and give us guidance, for example, from how the statistical authorities of each country deal with their data. There are some, the United States have quite specific guidelines on how to treat medical data, the HIPAA rules that provide a set of directions on how to change, to remove the names, to change the zip codes, and do a specific data transformation that they believe is enough to protect the user privacy, and such legal frameworks can be used as guidance on how to anonymize the data and how to automate some things. But still, the user has to be heavily involved on guiding the anonymization process. It's not as simple as pressing a button and the data becoming anonymous. Now, an important also thing is when to anonymize. When people discuss about safety of personal data, they usually provide a list of techniques that help anonymization, encryption. An important thing is to see the distinction between encryption and anonymization. Anonymization is suitable when you want to share data with third parties that you do not fully trust or that you are not allowed to give personal data. the recipient of the anonymized data will not be able to infer the identities or to attribute properties to natural persons. On the other hand, if you encrypt the data, what you guarantee is that the channel for transferring the data is safe. When you give encrypted data to someone, you usually give them the key to decrypt them, right? Because this is the way to use them. So encryption usually protects you from people who are not authorized to see the data. Anonymization protects you from people that you authorize to see the data, but you do not fully trust. They're complementary, but they do not achieve the same goal. One thing that you get away with, at least according to GDPR, is that when you have anonymized data, they're no longer personal, and you no longer need consent from users on how to use them. For example, a good case for anonymizing data is to provide them as open data. If you want to give something as open data, getting them anonymized is essential. On the other hand, encryption would not work, because if you give openly encrypted data without providing the key, they would be useless to every recipient. And the final thing is that the data you're using, actually the data analysis that you want to use on the data has some tolerance on noise and reduced information quality. If you need the exact original data, then anonymization won't help you. You have to find some other legal way on sharing the data. Now, why should one use amnesia? I can think for many reasons, but I can tell you a few compared to the rest that is out there. First of all, there are not, to the best of my knowledge, there are no real commercial tools that do data anonymization. Big vendors of databases do not have anonymization algorithms embedded. They do have some techniques on obscuring the data, like masking or some encryption, but they do not have data anonymization tools. The tools that are out there are like Amnesia, academic prototypes. It's a new market, and they're slowly starting to be integrated in other systems. So one benefit and one goal for us in developing Amnesia is that it's user-friendly. When you use it, you might find it quite complex because there are many choices that you have to do, but we made significant effort to visualize the results, to make the all the options that you have as simple as possible, to have recommendations, because we understand that it's a new process, it's a new thing, and users will need quite a lot of help to do it. Amnesia also it works with a clear distinction between the front end and the back end, so you can use it over the internet, and we have it online, but we have made certain, and we give it as a download, as a standalone application, so you can use it locally in your own premises. This is quite important when dealing with personal data, because usually you're legally restricted, or it's quite natural that a user won't trust to send the personal data over the internet to an unknown server, get them anonymized there and get them back. So we have Amnesia online for demo and training purposes, but you can, if you want to use it on your own data sets for real data, you can download it and use it locally. We have in parallel with making the user friendly, we have provided the user with many choices, which sometimes undermines the user-friendly idea, but we have to give the user many choices on how to guide the anonymization. So in any case, they will be able to guide the anonymization process, especially with regard to the information loss. This means that they can choose which parts of the data will be most heavily impacted by the data transformation and which will be preserved as best as possible. And this is very important when you have to do a data analysis. For example, if you have descriptions of persons, for example, you have the area where they live in and you have the age, maybe for your analysis, the age part is more important than the area. So in a way, you have to tell this to the algorithm that it will be preferable to sacrifice the accuracy of the home of their address than the accuracy of their age. We do have some unique data and transformations that we have developed, and especially for complex and sparse multidimensional data, set value data. This is the data that you get, for example, from a supermarket, where you get a list of products that is of arbitrary size. This is what you get actually from every retail store, credit cards. And despite being a complex problem, it is a quite common problem in practice. And to this end, we have developed a new privacy guarantee, KM anonymity. It has been published in some of the most important venues in data management, VLDB and VLDBJ. And we have an implementation in Amnesia where you can use it to anonymize high dimensional data. And finally, Amnesia is easy to incorporate in third-party systems. As I told you before, there's a clear distinction between the user interface and the anonymization engine. So if you're a developer and you have some other information system, you can just incorporate the anonymization engine to your own interface, or to make it work directly with the REST modules of your information system. So to go, okay, here's some statistics. Till now, that since we got Amnesia up to the opener, we had more than 63,000 visitors, 190K page views, and more than 3,000 downloads of Amnesia. And the current status is that we actually focus now on K-anonymity and KM anonymity. We have put a lot of effort to make them applicable to different data sets, which can be simple relational tables. For those that are not familiar, this is just an Excel table, to object relational tables. This means that some of the attributes, some columns in Excel might be complicated. They might have a list of products, like the ones I mentioned in the example of products bought from a supermarket. This is a common case in practice. And we have also put emphasis on the scalability. So we have algorithms that work with very large data sets that reside on the hard disk and do not fit in main memory. To help with integration with third parties, we do have an API, a REST API, and a command line API. So if you want to make it work with other information systems directly, you can just hit the REST API and communicate with the anonymization engine by bypassing the graphical and the user interface. And this helps Amnesia being part of larger solutions. And the last thing is that Amnesia is now online for more than 2 years. It is its basic features are no longer beta. Bugs have been diminished. We had some feedback, so we had a lot of feedback, so it's quite stable. Of course, it's time we add a new feature. There's a testing period, but all the basic methods have been tested, and now it is reliable, and you can use it for real work. So I gave you till now the framework about how to use a data anonymization and what Amnesia will do, but I have not actually provided you an example of data anonymization methods, and I expect that most of you are not familiar with it. So I will give you an example of the most basic methods we use, the k-anonymity. This is one of the oldest data anonymization methods that have been introduced. It is one of the simpler and maybe the weaker, but at the same time, it is k-anonymity introduces less information loss than more strict methods. And in general, this is a rule that holds for every privacy guarantee. The stronger the privacy guarantee, the greater the information loss. So k-anonymity also is quite straightforward interpretation of GDPR and other similar legislation, since what it does is it prohibits third parties from identifying, from linking a specific record to a specific person. Imagine, for example, that you have this very simplified medical data set where you have personal records that have been pseudo-anonymized. They are no longer names, they are no longer social security numbers or other direct identifiers, but you have for each person the zip code, the age, the nationality, and the disease that they have been diagnosed with. So if we release the data as they are, then a third party who has some background information that knows that, for example, Ivan is Russian and he's 20 years old, they can use this information to directly identify, to easily identify the record that belongs to Ivan, which here is the first record, and they can easily see that he suffers from heart disease. So by using some background knowledge or some other external catalog, for example, you can have, as they had in the United States, voter catalogs who have had the date of birth and the zip code, and you can use such third-party information to link it with the pseudo-anonymized data and re-identify every record. So that's why this is considered pseudo-anonymization, because there is a way to reverse the anonymization process that has taken place. So the idea with k-anonymity is to guarantee that every record will be indistinguishable from other k-1 records. That means every k records will be the same, more or less. They will be the same with respect to the pieces of information that can be used to re-identify the persons. And in this case, we call these pieces of information quasi-identifiers, and in this case, they are the zip code, the age, and the nationality. We decide which parts of the information can be used as quasi-identifiers based on our estimation, which attributes might be available from other sources. So what the data anonymization algorithm will do is that it will reduce the accuracy of these attributes, so that any combination of these attributes actually appears k times. For example, if now a third party looks at the table on the right, the for anonymous table, then and he knows background information about Ivan, that he's 28 years old in his Russian. The only thing that they can infer is that Ivan's record is one of the first 4 records, because these are the only records where the age category is less than 30, and they cannot decide if he has heart disease or viral infection. So the data transformation here completely removed the nationality, it removed the accuracy of the zip code, and it transformed the exact age to an age category. And this way we have a guarantee that a third party that knows the quasi identifiers cannot go back and identify a person. Still, I have this as an example, although I will not delve deeper in this presentation, that even if the identity of a person cannot be revealed, some properties might be attributed for a person. For example, if you know that a person here is at their 30s, you can infer that they will suffer from cancer, because all persons in their 30s suffer from cancer in this data set. So further steps can be taken to alleviate this kind of dangers, but we will not go deep into this kind of problems here. In any case, here you have a formal guarantee that the data transformation is not reversible. An important input that has to be provided by the user, and we will see how we do that with amnesia, is to provide rules for generalizing the data. I will go back, actually. You see here, we decided to remove some digits from the zip code, or to transform the age in age categories. The algorithm cannot completely guess that by itself. We have to provide rules saying that, you know, if you cannot achieve k-anonymity, remove the last digit of the zip code. If you still cannot achieve it, remove the 2 last digits, and then the 3. Or in the age, you can instruct the algorithm, if you cannot achieve k-anonymity with exact age, then get a 5-year age category, transform every age to its 5-year age category. For example, 28 could become 25 to 30. If this is not enough, then go to 20 to 30, and then finally go to this kind of categories that we have here. To provide this information, we do it by creating a generalization hierarchy, where we start from the more specific values, and then we give instruction to the algorithms how to gradually remove the data accuracy. For example, if you had numbers, there can be ages, you can say that first present the decade where someone has been born, then present the 20-year period, then half a year period, or at the end of the day, just say the century, or nothing at all. And this has to be done for every domain that appears in the quasi identifiers. So this is the part of the input in the data anonymization that requires the greatest effort with respect from the user. This is k-anonymity. I don't know if I will just say the basic idea quickly, and then we can go directly and see how amnesia works, which I think is most important for this first presentation. K-anonymity is suitable for sparse multidimensional data. Think, for example, that we go to a supermarket and we buy 20 products. That is 20 products out of the 20,000 different products that a supermarket has. So if we consider every bit of information about if we bought a product or we didn't buy a product as a different quasi-identifier, this would make a record with 20,000 attributes for each person, where yes, no would be the value of each attribute. And if we wanted to provide k-anonymity on that, because there's so many different combinations, we would actually be led quite quickly to not being able to publish anything. So what k-anonymity does, it says that the intuition is that in such large sparse data set, it is it is not reasonable to expect that third parties will have a complete knowledge of the products you bought or you didn't buy. The most reasonable assumption is that they will know some products that you bought. And we make an assumption that they will know up to M products. So what anonymity guarantees is that every party who knows up to M different products, M different values from your record, then there will be at least K records that will have this combination of M values. For example, see here in the second table where the users that have bought products from a supermarket, any person who knows the combination of any two products will always have at least two records that match it. If someone knows that, okay, I keep the names here so you can see the example in the published data. Of course, there would be any names. If I know that Vasilis bought fruits and meat, then I would go to the records and see, oh, there are at least two records that had fruits and meat. If I know that Eleni brought some other food, and I know only one piece of information because Eleni actually bought only one thing, then there will be at least 4 records that have bought other food. So I will not be able to isolate less than 2 records if I know up to 2 different things that they bought in a supermarket. Okay, and this is the final thing from the presentation. It is the limitations of amnesia. We saw the general limitations of anonymization, and then some limitations more specific to amnesia and similar tools. The greatest limitation for us is since the users do not have experience with anonymization techniques, we have to present very detailed detailed documentation and put a lot of effort in having everything user-friendly. But still, if you're not familiar with anonymization, what you should do, it can be a bit difficult to use amnesia. So it requires some effort in using amnesia. Another thing that amnesia cannot do is it cannot decide on the user on the privacy parameters. When users try to use data anonymization, common question is, what's a good value for K? What's a good value for M? This is not something that amnesia can help them with. They have to decide it on themselves based on best practices and their estimation of the risk. And of course, amnesia at this point provides 2 kinds of guarantees: k-anonymity, and km anonymity. These protect against some large families of attacks, but not against everything. We plan to add differential privacy, but in general, there are always some more attacks and more privacy guarantees that can be incorporated. So that was it, and I will go now show you the demo. I don't know how the organizers want to do it, if we can have questions now or okay.
You may proceed, Manolis, with the demo, because I see there are no questions there yet.
Okay. Okay, I think we're back, so I will hurry a bit with the demo, and give me a moment, I have to share again. Okay. This is Amnesia. If you open it, then you start with this page. The process, the basic steps are simple. You have to upload the data with the personal records. When I say upload, is upload to Amnesia. If you have Amnesia locally, nothing will leave your premises. Amnesia will just be loaded to your data file will just be loaded to Amnesia. So the way we import data is similar to how text data is imported to Excel. So I will use here the simplest example. The data here are in CSV files. I just provide as a parameter to Amnesia the delimiter to distinguish different columns, and Amnesia loads the data. It guesses the type of the data based on the first record, so they might be wrong, or we might want some data to be treated in a different way, so the user can change this. In this example, all the guesses are correct. And now, by checking and unchecking some of the columns, we decide which of them will be loaded in the tool. Since we want to anonymize the data, obviously we're going to leave out the direct identifiers. This is a synthetic data file that resembles the data records from British hospitals. It's data similar to what we used in a project. And I'm leaving out the identification number and also their names. By leaving these out, the data are pseudonymized. You have diagnosis code, we have date of birth, we have their marital status. So these data are already pseudonymized, but we want to make them really anonymized. So for this scenario, I will assume that the date of birth and the marital status can be used as quasi-identifiers. These are the diagnosis codes. It's a kind of coded way of presenting the diagnosis that has been done from every patient. We assume, at least for this scenario, that this cannot be used as identifier, that no third parties can know this. So if a user is to be identified, it will be through these two fields. So we have to give directions to the algorithm on how to generalize, how to gradually abstract these two fields based on its needs to achieve the desired privacy guarantee. For the marital status, we have prepared and created a generalization hierarchy in advance. This has been created manually based on the values we get in the data set. Now, this is a real data set. So when people write down the values, it doesn't mean they come from always from a predefined ontology of vocabulary. So here, and this is how it was in the real data set, some have not answered, some in married status simply wrote no, others wrote divorced, widowed. We group these to single and then to any. So the algorithm, if it needs to generalize this field, it will replace these values with single, and if this still is not enough, it will replace them with any. Now, Amnesia allows the user to to semi-automatically create the generalization hierarchy. This works best for continuous domains, numbers, dates, and it's harder with domains that have categorical data. The basic idea is that Amnesia reads the input data and then puts all fields, gets all values and groups them to categories according to the directions of the user. Now, if this is a continuous domain, we can define a step and then the fan out of the generalization tree. That means how many children should each node have in the generalization hierarchy. So you can say that if you have numbers, get a step of 10. So every 1 to 10, 11 to 20 will create a different node, and then you can instruct it to group this node, every 5 nodes to a new node till we reach 1 node. If the data are categorical, just strings, then you can only define how many values should be grouped together, and this will be grouped randomly. So it is harder to get something meaningful out of that, but with continuous data, this works better. Now, with date is the most complicated continuous value, because we do not use the decimal system. We have weeks with 7 days, we have years with 12 months, and so on. So instead of just giving one step, just group the data based on for every 10 in the range, we have to give a range in terms of days, a range in terms of months, a range in terms of years, and then how values will be grouped from then on. So I wanted to create 3-year ranges, 3-month ranges, 7 days ranges, and then the 3-year ranges should be again grouped to nodes with 3 children. And I get something like this. So here the 7 day, every 7 days we have 1 node, every 3 months we have 1 node, every 3 years we have 1 node, and from here on every 3 nodes get to a single node till we go up to a single node at the root of the hierarchy. Now that we have created the hierarchies, we have to bind them to attributes, basically say to the algorithm that you will use the date hierarchy for the attribute date of birth, and you will use the marriage hierarchy for the attribute marital status, and then we want k anonymity with k equal to 3, and voila, you get a lattice of solutions. Now, what is a lattice of solutions? You might, oh, sorry, again, I have a cut again. Every node here represents a different generalization. For example, this node means that the algorithm has generalized the date of birth 3 times. It has gone up to the generalization tree 3 steps, and has not generalized at all the marital status. The 3, 0. The 2, 1 means that it has generalized date of birth twice and the marital status once. Red nodes signify solutions that do not mean the 3 anonymous threshold. They're not safe solutions, and blue ones are safe solutions. So the most obvious usage of the graph is that you can choose, depending on how important everything is, if you prefer the marital status to remain as it is and lose more information on the date of birth, or lose less information on the date of birth and lose some on the marital status. And also there is a choice that sometimes you do not achieve the required protection because of a few records. For example, here, if we only generalize the date of birth 3 times, it is 12% of the records that do not fall in this, that violate the desired privacy guarantee. So instead of further generalizing, we can simply delete the records that do not adhere to the privacy guarantee. Okay, here is a big percent. There are other cases that might be 0.3%. So we can delete those, apply the solution, and then here we have the original data, here we have the anonymized data, and with red color is the records that have been deleted and they will not be saved to the output. So the date of birth, instead of being a specific date, it's now a 3-year period, and the marital status has remained unchanged in this kind of anonymization. And now we simply save locally to Zenodo the anonymization, the anonymized data, and we're done. So I think I'm on time, and this covers both amnesia and the anonymization presentation. I know that it's a lot and it's complicated, so please feel free to make any questions, and if you have things that we cannot cover today or now, please do not hesitate to contact me through my mail. So that's all for me.
Thank you, Manolis. And I don't know how much people enjoyed your presentation, because I don't see any questions, but perhaps the reason is that everything was clear, so they were able to follow the logical flow of everything there. Of course, it's one thing how easy things appear in a demo and how easy they are for a user or an end user to get familiar and accustomed to some tool. And now we proceed to the last session for today, and it will be Eli and Gültekin again, and it is about writing data management plans. And I hope we will manage to have also some little time for reflections at the end. Otherwise, we will conclude our session, and please provide any questions that you would like to get answered, not only about the session that will now follow, but also about previous sessions. Okay?
Thanks a lot. Bye.
I see there is one question there. Oh, it is someone praises you, that it is a great tool, and they thank you.
Okay,
yeah.
Thank you very much.
Yeah. And just a comment there, because Manolis kept a very low profile. This is usually people who are computer scientists. They keep a very low profile. They build things, but it's not their thing to communicate, and they are not very extroverted. But we enjoyed very much your presentation, Manolis. So, Eli and Gültekin, the floor is yours.
All right.
Thank you. Yes.
Thank you. So let's start by looking a bit in more details of what data management planning is and how Argus can help you with your building your data management plans in a machine actionable way. We'll start. An introduction about data management plans was given by Emily, who unfortunately had to leave earlier because I see that she wrote in the chat, but we thank her for her time and for her presentation. So let's see why DMPs are important and how we can implement the DMP and write a DMP. As we mentioned, the data management plan, short for DMP, I will call it for now, it's a deliverable of the Horizon 2020 for Horizon 2020 projects, and it's a living document, meaning that we write it. It's essentially a document at the end. It's like a text document, the output, the product after this process. And it's a living document, meaning that we should keep it and we should go back and update it at any time during the research project and the research data management lifecycle that we saw, so that we include more information about the data that we have been analyzing and maybe we have tweaked and modified during this process, or about new data that we might have produced during the activities of the project. So we can always go back and add new things and modify previous things, so that we give more context of what has already been there at the beginning. So there we document the processes undertaken throughout data management lifecycle, including the costs, as we saw in the previous session. So there is the place where we also write down the costs that we have planned and the resources allocated for the data management activities. But what we shouldn't confuse data management planning for being is a research assessment method. It's not a method where your research, according to which your research is assessed. It is just a tool that shows the steps that you have undertaken, so that other researchers can take it and can guide it through what you did, so that if they take and they reuse your data, they can reproduce your data, but also they can build on top of your data based on your based on the information that you have provided there. Also, they can see how well you validated your findings are. What data does the data management plan cover? Are scientific data and metadata, meaning that these are data and metadata that are useful for verifying and validating the conclusions that you write in the papers, in the scientific publications. So every peer-reviewed, let's say, publication might require, so most of the publishers now require for you to also share your data, which then the Commission also wants you to deposit them under a repository. And this is why it's important. Those data that you will deposit are those data that you have worked throughout the research and that are useful for validation of the conclusions that you write in the publication. You can also deposit and preserve other types of data, like raw data, meaning unprocessed data that you take from a sensor without processing them, without doing anything on them, or structured data and metadata that are that haven't been used for the publication, for the conclusions of the publication. So they don't validate those findings, but they are somehow useful. They can be used in further in other research projects or in other activities, rather than this particular publication or particular publications that we might want to validate. These raw or structured data can have guidelines for data reproducibility or include also an analysis tool or software. This means that you can also include in the DMP the tools that you might have used or you might have developed to analyze your data, so that people can reuse your data, take the software that you have used, and get the same results as you did. We're talking about data that do not infringe copyright, of course, and we saw that the license clearance tool that we mentioned in the previous session can be used in order for you to understand. If it's not clear how you can use some data, you can use it to get guided through a process that you understand if a dataset is copyrighted, if you can have derivative works out of it. So there are tools, as we saw, that can help you understand if and how you can use data sets that do not clearly say or state any copyrights. So having done all the processes of copyright clearance, for example, we make sure that that doesn't infringe, those data don't infringe copyright and are non-personal and sensitive content. And if they are, we saw before from Manoli's presentation that if we have personal or sensitive, let's say, data, we can anonymize them in some occasions so that we can, so that the GDPR does not apply, and we can share them with, let's say, more openly with the research community. But we, for those two occasions, we have to apply access restrictions, of course, which we have to address and yes, we have to address in the data management plan, but also in advance to the research project starting. So at the proposal stage, even that we are going to use this data that do not infringe the copyright and that are sensitive content, and we're going to be handling them accordingly and applying all those methods for anonymization and so on. So we make sure that we state exactly the steps that we'll undertake. And then, of course, when we have the grant, where we have the grant, we make sure that we implement all this and describe them again on the next version, a new version of the data management plan. You remember we said it's a living document, so we go back and add things. When is it delivered? The data management plan is delivered at the proposal stage. It is not necessarily to deliver it at the proposal stage of the project, but it's something that can give you possibly credits for doing so, because you show that you are following, that you are committed, let's say, to the open science principles and research data management in particular. For the proposal stage, you need to include minimum information, because it's understandable that you won't have a good, let's say, that you won't have agreed on the particular tools that you will be using or on specific methods and so on. So maybe minimum information that you can include is what kind of data will the project create or collect, that you know already at the conceptual level of the project, which standards will be used for those data, how will the data be shared or made available, and if they cannot be shared, how and why they cannot be shared. For example, if they are sensitive data and you don't want to, they are not subject to anonymization, then you have to restrict their access, so you have to say that. And how will this data be curated and preserved? And again, you see that sharing and preservation are very important, as we saw yesterday also, for open access and open science. So you have to make sure that you mention any repository, maybe Aperta, for example, or Zenoro, or rather the repositories that ensure preservation. At the project stage, it's important to have and submit a DMP on the 6th month of it's a deliverable. When we have the grant, it's deliverable, but should be submitted on the first 6 months of the project. And the first version can have all this information and maybe few details on all this information. And yes, maybe you have agreed already on where you're going to deposit and so on. So more details on the questions of the template. You can have revisions after the first 6 months, and at the end produce a final version of your DMP, which will be more coherent, let's say, and more complete, as you will have finished all the data activities, and you will be able to say in more details and more accurately, let's say, address some things that are some questions that are included in the data management planning templates. Who is involved with data management planning? It's funders, of course. They define the rules for data management plans. It's organizations like policy offices, which define the policies. Projects like project managers who have to apply those policies and align them. Data managers who manage the data management plan, and researchers who are those that are dealing with the data and they can describe the data sets. They know what they have been applying, what are the standards that they used, what are the different methods, so they can describe the data sets and get attributed by sharing their data sets. The value for DMPs is to increase the quality, of course, of research, and therefore by doing that we make sure that quality, meaning that someone can validate the results that are included in publications, and they can also reuse, not only validate the results, but also reuse our data in their own research. So by increasing the quality, then we also increase our own prestige, because we show that as researchers, we show that we are, let's say, people can trust our research, and that can lead to more collaborations, etc. So it's very it's also another benefit. To ensure we can use the DMPs to ensure that research outputs, including data in particular, are findable by everyone and available to people, so that we make sure that by reading the DMP, they can find exactly where data are located and how they are described. DMPs also help with avoiding duplications of same research concepts. Like, for example, it's easier. It helps avoid duplications of the same research concepts. It helps to see what has been done wrong in previous, let's say, research efforts, and don't make the same mistake again. To understand strengths and weaknesses, example, what discipline or unit produces more results, and where data are described based on the DMP requirements. It's important, let's say, to understand where areas, where disciplines, not all disciplines are that mature in terms of FAIR, and this is something that FAIR, as we saw, is something very deep into the European research area at the moment. So it's important for us to understand also what's missing from those disciplines, and where we can contribute as research communities to strengthen some of the elements. Like, for example, there might be disciplines or specific areas in the disciplines that do not have a metadata standard. There are live examples that this exists. So we should make sure that we can then find those gaps and address them, and create a new metadata standard, for example. And then DMPs are important to ensure research integrity and excellence of researchers. Again, for the same reasons that we saw previously, for validation of results and proper quality of data. Now, moving on to Argos. Argos is a service that is provided by OpenAir. It was developed in collaboration with EUDA, the European Data Service, and it's an open source, configurable and extensible tool, meaning that it's open source, so you can take it and you can deploy it. You can follow the documentation and deploy it in your own institution, for example, if you want to have own installations. It's configurable, so people, and by being configurable and open source, this provides, for example, and extensible. These elements provide flexibility and to developers and allow them to contribute when they want, for example, to push new features where they see that the research community needs new features. They can do that by pushing the recommendations through our repository, the open source repository. Research communities can configure their own APIs so that we make sure that we address as much as accurately if we can all the demands coming from different disciplines. And of course, Argos is, as I mentioned, a data management planning tool. So you use it to create your data management plans, following templates that are compliant, let's say, to open access and fair data policies. So they support the open access and fair data policies of funders or of institutions. A website, you can find Argos at argos.openair.eu, and we currently have more than 1,100 users, and we're still growing because we are the newest member of the OpenAir tools. Yes, so our user database, our user base, let's say, is still growing. I mentioned that we can have you can have ad hoc installations, but also online installations. If you are an institution, you want to have your own installation for Argos. Otherwise, researchers are free to use it and very without any barrier use it and write their data management plan, following the steps that I will show you later. And also Argos is available in EOS, so it's an EOS resource, which is also worth mentioning. This is how a life cycle in Argos looks like. So you start by, writing the basic information. All right, here with the DMP editor, you write the administrative information, like what is the project that you are working on, that you are writing this data management planning for, what is the grant of this project, who are the authors of this data management plan, what's the description of this project, a basic information that helps understand, give a bit of context for why we're creating this data management plan and who are the beneficiaries and the key people that we are doing this for, like the funders. And then once we have the administrative information, we can add as many data sets as we want. So we can we can describe as many data sets as we want, given the data sets that we have produced in the project. Like, for example, we might have a project that doesn't produce many data sets, so it has only 2 or 3 data sets. We can add only 3, or there are more data intensive, let's say, projects that we might have more than 10 data sets to describe. And the good thing with the dataset editor is that it is very flexible and sensitive to what information each dataset has, and you can use it to describe one dataset per its type. For example, if it's a statistical dataset, you can describe the statistical dataset here with its own metadata, its own PIDs and vocabularies used, etc. And then you can add another dataset description to describe, for example, a dataset that you have for oceanography, which has different metadata standards, use different vocabularies, use different repositories that it might be deposited after. So all these different elements you can find in the dataset editor. And once you have all this information, once you have provided all this information, then you can validate your DMP, your complete DMP, meaning that this is a first set of validation that you just we just check if you have completed all the mandatory fields. This is a basic validation. Then you can finalize your DMP and either leave it in Argos, publicly or privately. Privately meaning that you will be the only person that can access it from Argos, or any other people that you have shared it with to contribute. So any other contributors, colleagues that you have shared it with, you will be the only people that will be able to see it and consult it. Otherwise, you can alter the access mode and open it for public consultation by others. We have public collections of DMPs and datasets that you can use, that our users can use to get inspiration from. And once you have done that, you might also want to deposit it and publish your data management plan according to open and fair principles, publish it on a repository. We have integrated Zenodo, which is the opener and CERN repository. So that way, you also get a DOI, your DMP gets a DOI, a digital object identifier, and they can be versioned at any time in the published record. So once this process is finalized, what you get is a machine actionable DMP output that follows the open and fair principles. So it's versioned, you keep the history of the different things. It has a DOI, it has a license, which is very important for us to provide licenses to DMP outputs. Maybe you have realized that sometimes we find something, especially DMPs, that we don't know how to reuse them. So it's important to assign a license to our DMPs. And at the end, we have a rich document rather than a text document that we would have if we had only just created it by, for example, opening our Word office, our Word office, or a Google Doc or whatever. And it's rich because throughout the whole process, we have integrated opener APIs and the EOS API so that we make the links with the different entities in the open science ecosystem, and that were described yesterday by Alessia in the research graph of the different entities. And then we have also applied the DMP common standard, so we ensure interoperability of DMPs across systems. So this is why they're rich and they're not just plain documents. They are discoverable and versioned and accessible, reusable, and preserved because we follow all these different Why do you use Argos? Because not only it provides a full DMP generation and publication process, so your DMPs are open as open and fair as possible at the end, but because we try to normalize the descriptions of the data and provide control over the data set that is described each time, and not and be able to, by doing that, by giving control over the single data set of a DMP, we acknowledge the different criteria that apply to different status, or to different data statuses, or to different data types, or to different data that are in different disciplines. Let's say there are different needs that have to be met each time. So we try to support interdisciplinarity and multidisciplinarity of DMPs, because there are different criteria, as I mentioned, applying for produced data, so new data that are now produced, different things that apply for reused data, meaning that, again, we have to see if we're reusing something, does it have copyright, does it have license, how to use it, all these different things. Sensitive data set, how do I share it? Argos provides the possibility to exclude this data set description before you publish your DMP, for example. This is very important for us. And also discipline-specific data sets can be described with exactly the data set, the standards that apply for these particular disciplines. Then we connect with opener. We'll show you in a minute how this is done, and this is very important. We saw that linking It's also mentioned in the FAIRM principles that linking from a resource to another, it's very important. And we also try to standardize practices by collaborating also with others, like for example, with properly exposing in repositories the DMPs in the appropriate way, because we see that this is something that not everyone follows with having the correct resource type. Main users are researchers, research projects, funders, research communities and institutions, and Argos is for funders who can use it who can have their own installations, let's say, to enrich the templates collection that we have with their own templates, their own DMP templates, like the TÜBİTAK template, translate the tool in the native language so that researchers find it more easier to use, native researchers, customize open and fair guides with their own guidelines that they have, and link with the funder monitoring dashboard. Other things that they can do is configure the APIs, link with their national open science graphs, and integrate their own services such as researchers registry. And currently we are working with Xistera and FGT, which is FGT is for the Portuguese funder, to support their DMP efforts. The Xistera example is here. This is their template, and we use it to support, and we collaborate with them to provide policy support, training, funder monitoring, dashboard, and minimal configuration of Argos features. Research institutions can use it to enrich the templates, customize their own guides as previously shown, configure their own APIs and integrate their own services. And we have worked with Ariadne Plus in different, so we work with projects. Ariadne Plus is a project that is addressed to archaeology community. So we have collaborations, let's say, with different projects to implement and create discipline-specific templates to be used by their disciplines, because some templates, like for example the Horizon 2020 template, is very generic. So Ariadne Plus, for example, took the Horizon 2020 template, which is generic, as their basic, their starting point, and configured it to be more applicable to their needs as an archaeological community. So we work with different communities to do that and allow for machine actionable outputs, DMP outputs for these communities. Researchers can use it, it's free, as I mentioned. You can get guided through open and fair RDM through the tool and familiarize yourselves with DMP process. You can choose templates that you want to describe your datasets with, like the Horizon 2020 and the TÜBİTAK, if we're talking about national templates. You can describe different types of datasets there, produced, reused, sensitive datasets, and so on, and clearly distinct each one with the other. And you can share the DMPs with colleagues to manage workload, create new DMP versions. It's a living document. You can create new versions at any time and publish DMPs directly in Zenodo. So I will show you now, I'll leave this. I will show you how Argos demo. Here is the TÜBİTAK template in Argos. As you can see, Argos has a localization in Turkish. So you can find Argos in Turkish, and you can also find this is not available at the moment in the production, but it will be by the end of the month. So you will be able also to view this in the production at argos.openet.eu and complete your DMP there. We're thankful for this localization, for this localization, yes, for the Turkish Higher Education Council Research Data and Open Data Working Group, because they helped and they put the effort to make this happen with the localization. We have, I'm not going to go into much detail because I think that we're running out of time. I just wanted to show you the links that are created behind Argos. We try to support the links with different providers so that we make it easier for repositories, for example, to organize themselves especially if we're talking about big data and data that data intensive activities. But anyway, we create links with these different tools, and we make Argos outputs available and searchable through Open Explorer. The takeaway is that Argos prepares all stakeholders for the next Horizon Europe DMP's requirements. It simplifies administrative processes and connects with university and institutional workflows, and it enables research communities to create templates tailored to domain standards and practices. And thank you. I think I now have to quickly, how much time do I have? Because I think that the PDF that I have the time is not the correct one. If Adamantis, if you can tell me how much time do I have?
Actually, we have 20 minutes, 20
Okay,
full minutes, and we can go with them as best as you prefer. Yeah.
Okay, then Gültekin can follow, and we'll see how we go there. But I'm happy to answer any questions, the Q&A in the meantime. Thank you.
Okay. Thank you, Ali. Tekrar merhaba. Günün bu saatinde hala baktığımda 60-65 civarında katılımcının olduğunu görüyorum. O gerçekten mutluluk verici. Biliyorum kolay değil. Hepsi birçok araştırmacı için çok yeni konular. O yüzden de izlemesi de, takip etmesi de, anlaması da hiç kolay değil. Ama bu 2 gün boyunca bizler OpenAIR ekibi olarak ve TÜBİTAK'taki arkadaşlarımızla sizlere özellikle Avrupa Birliği için açık bilimin en önemli yapıtaşlarından biri olan araştırma verilerinin yönetimi, nasıl araştırma verilerimizle ilgili repository bulabiliriz, yani veri arşivi bulabiliriz, standartlar nedir, FAIR nedir ve bunlarla ilgili neler yapabiliriz, bundan ilgili rehberler var mıdır, işte projelerle nasıl ilişkilendirebiliriz gibi birçok konuda aslında bilgi vermeye çalıştık. Ben de sizlere çok hızlı bir şekilde bu günün son oturumunda birazcık daha arkadaşlarımın tekrarı gibi olacak ama zararı yok. Çünkü veri yönetimi konusu çok önemli ve veri yönetimi konusunun ülkemizde de oturması gerekiyor. Herkesin en azından veri yönetimi dediğimiz zaman aynı şeyleri anlaması gerekiyor. Kısaca bir kez daha üzerinden geçmek gerekirse veri yönetim planı yeni bir araştırmaya başlamadan önce araştırmacı tarafından çalışmada kullanılacak verilerin, yani daha önceden üretilmiş verilerin veya çalışma süresince ve çalışma tamamlandıktan sonra elde edilecek verilerin nasıl yönetileceğinin, diğer bir ifadeyle aslında veri yönetimindeki yaşam döngüsünün her adımının nasıl gerçekleşeceğinin anlatıldığı bir doküman. Şimdi veri yönetim planına geldiğimiz zaman arkadaşlarım da anlatıyorlar neler içerecek, neler olacak veri yönetim planında. Aslında temel olarak verileri nasıl toplanacak ve kullanılacak, etik konular nasıl yönetilecek, hangi dosya formatları kullanılacak, hangi dizim ve dosya adlandırma kuralı kullanılacak, araştırma sırasında veriler nasıl kullanılacak, araştırma sırasında veriler nasıl depolanacak veya yedeklenecek ve yine veri yönetiminden kimler sorumlu olacak, verinin uzun vadeli korunmasına yönelik plan nedir, örneğin hangi veriler muhafaza edilecek, paylaşılacak veya korunacak ve planın uygulanması için hangi kaynaklara ihtiyacı olacak gibi temel soruları içeren bir plan, veri yönetim planı. Ve arkadaşlarım da 2 gün boyunca dün ben de bahsettim. Bu konudaki en önemli bilmemiz gereken şey FAIR ve FAIR ilkeleri. Bunda bir kez daha tekrar edersek buradaki baş harflerden çıkma FAIR, findable, accessible, interoperable ve reusable, yani bulunabilir, erişilebilir, birlikte çalışabilir ve yeniden kullanılabilir olması gerekiyor. Bu prensipleri yerine getirdiğimiz zaman ancak verimiz açık ve başkalarının yararlanabileceği bir veri oluyor. Şimdi TÜBİTAK Veri Yönetim Planı'ndan da bahsetmek istiyorum. Demiştim dün de Ebru da sunumunda bahsetti. Aslında biz TÜBİTAK'ta da uzun zamandır bu konular üzerinde çalışıyoruz ve açık bilim politikasını geçen yıl TÜBİTAK kabul etti ve orada hem yayınların yanında verilerle ilgili de bir takım bilgiler vardı ve bu politikanın gereği olarak da en azından pilot olarak TÜBİTAK programlarından bir tanesinde bir an önce bu veri yönetim planında uygulanmasını hep konuştuk ve sonra da RDM işbirliğiyle en azından 1001 programında şimdi pilot olarak bu başladı. Veri yönetim planında TÜBİTAK neler soruyor? Biraz önceki bahsettiğim kriterler gibi aslında. Araştırma sırasında hangi tür veriler kullanılacak ve elde edilecek? Proje kapsamında elde edilecek, üretilecek veri paylaşım ve tekrar kullanım için uygun olacak mı? Bunu soruyor. Veriler araştırma devam ederken nerede saklanacak? Proje tamamladıktan sonra veriler uzun süre olarak nasıl saklanacak ve üçüncü taraflarla nasıl paylaşılacak? Verilere kimler erişecek? Ve TÜBİTAK'ın sunmuş olduğu veri koruma paylaşım planından farklı bir planınız var mı? Bunu soruyor. Ve araştırma sonrasında verilerin saklamak için hangi altyapı olanaklarınız var? Onlarla ilgili bilgiler sunuyor. Varsa da ekleyeceğiniz diğer hususları soruyor. Şimdi bu sorular üzerinden kısaca bazı ipuçları vererek bahsetmek istiyorum. Burada araştırma sırasında hangi tür veriler toplanıyor? Burada veri kaynağınız ne olacak? Verileri nasıl toplayacaksınız? Örneğin geçenlerde biz İzmir Yüksek Teknoloji Üniversitesi bir hocamız için bir veri yönetim planı hazırlarken işte bu sorunun karşılığında işte hocamız dedi ki işte sismolojik veriler, fiber optik sensör verileri, korelasyon verileri gibi verileri toplayacağız ve bunları toplama ve üretme nedeni ve projeyle ilişkisini orada anlatmanız gerekiyor. Sonra proje kapsamında toplanacak verilerin büyüklüğünü öngörmeniz gerekiyor ve bundan ilgili bir bilgi vermeniz gerekiyor. Tabii ki bunların hepsini öngöremezsiniz. Biraz sonra en sondaki notlar bölümünde söyleyeceğim. Bazı bilgileri proje süresince veri yönetim planınızı güncelleyerek de sonradan da değiştirip ekleyebilirsiniz. Ve size sorduğu şeylerden bir tanesi hangi tür formatlarda verinin toplanacağı. Yani işte diyelim ki siz depremle ilgili araştırma yapıyorsunuz ve Kandilli Hastanesi'nden bir takım veriler aldınız. Bu verileri nasıl alıyorsunuz? Mesela Kandilli Hastanesi CSV şeklinde mi veriyor verileri? Bu şekilde mi toplayacaksınız? Bu veri formatlarının tanımlanması gerekiyor. Var olan herhangi bir verinin yeniden kullanıp kullanılmayacağı, bu da çok önemli. Yine Kandilli örneğinden verirsem, depremle ilgili bir takım tahminlerde ve depremleri takip ediyorlar ve o verileri onlar tutuyorlar. Siz de kendi araştırmanızda bu verileri kullanacaksanız bu verileri nasıl alacaksınız, nasıl kullanacaksınız bunlarla ilgili bilgi veriyorsunuz. Ve en önemlisi de bu verilerin kime nasıl bir yarar sağlayacağını bu planda belirtiyorsunuz. Şimdi hangi tür veriler toplanacak dediğimiz zaman birazcık böyle kafamızda bir resim oluşması için veri tipleriyle ilgili de bazı şeyler söylemek istiyorum. Bazı ipuçları vermek istiyorum. Bunlar sayısal veriler olabilir, dokümanlar olabilir, laboratuvar notları, anketler, ses ve video kayıtları, fotoğraflar, filmler, tarih eserler, laboratuvar numuneleri, modeller gibi ekranda gördüğünüz birçok tipte veri olabilir. Burada 2 gün boyunca aslında bahsettiğimiz en önemli şeylerden biri de birlikte çalışabilirlik standartlarıydı ve verinin yeniden kullanıma uygun olmasıydı. Burada da verinin türü kadar verinin formatı da önemli ve tavsiye edilen formatlar var. Özellikle işte burada bir takım mesela nice veriler toplayacaksanız bunların işte SPSS olması, SSS olması veya Microsoft Access olması gibi ya da işte niceliksel veriler toplayacaksanız bunu PDF olması yerine işte CSV olması, XLS olması gibi burada dosya formatları aslında yeniden kullanım için ve birlikte çalışılabilirliği için tavsiye edilen formatlar var. Bunları da buradan görebilirsiniz. Yine araştırma verilerinizin yönetiminde verilerin tamamlanmasında kullanılan dizim ve dosya adlandırma şekliniz çok önemli. Çünkü bunlar size çok büyük kolaylıklar sağlayacak. ULAKBİM açık veri portalında da mevcut şu anki ekranda gördüğünüz doğru isimlendirme ve dizin adlarını belirleme formatı. Yine bunu da çok rahatlıkla veri yönetim planınızı oluştururken veya verilerinizi yönetirken bu kodlamayı rahatlıkla kullanabilirsiniz. Yine proje kapsamında elde edilecek, üretilecek verilerin paylaşımı ve tekrar kullanıma uygun olacağını soruyordu TÜBİTAK. Evet, burada yeni araştırmaların yapılabilmesi için yardımcı olacak mı? Yeniden kullanılmasına olanak sağlayabilecek mi? Bunu burada belirtiyoruz. Sizin bulgarınızın değerlendirilmesi noktasında kullanılabilecek mi? Ve verilerinizi paylaşırsanız ve paylaştığınızda eğitim öğretime katkısı olacak mı? Oradaki faaliyetlerde kullanılabilecek mi? Ve deneyimlerin tekrar edilmesi gibi durumlarda paylaşım ve tekrar kullanıma uygun olacak mı gibi sorularına cevaplarını burada bu şekilde verebilirsiniz. Diğer önemli bir konu veriler, araştırmalar devam ederken nerede saklanacak? Şu anki en büyük problemlerden, krizlerden bir tanesi, birçoğunun başına da gelmiştir. İşte eğer verilerinizi PC'nizin hard diskinde, flash belleklerde, CD'lerde, disketlerde, buralarda eğer buralara koyarsanız bunlar zarar gördüğü noktada bütün yaptığınız deneyleri, bütün yaptığınız testleri, bütün araştırmadaki çalışmalarınızı yenilemeniz gerekebilir. O yüzden çok riskli. O yüzden de işte Aperta açıldığı zaman Aperta'ya versiyon bilgisiyle beraber koyabilirsiniz. Üniversitenizde bir akademik arşiv varsa oraya koyabilirsiniz. Zenado'dan 2 gün boyunca bahsettik. Zenado gerçekten çok güvenli bir ortam. Zenado'ya koyabilirsiniz. Veya okulunuzda, üniversitenizde bir bulut servisi varsa bu bulut servisine koyabilirsiniz. Tabii bunun yanında da kolay olsun diye harici hard disklerde de tutabilirsiniz ama mutlaka güvenli olması ve kaybetme riskini mutlaka telafi edeceğiniz bir yöntem bulmanız gerekiyor. Burada diğer bu konudaki önemli konulardan bir tanesi ne kadar süreyle bunları saklayacaksınız? Genelde araştırma bittikten sonra 10 yıl gibi bir süre saklanmasıyla ilgili birçok fon sağlayıcının kuralları var. Burada ne kadar saklayacağınızı belirliyorsunuz. Verilerinizin planlanan yedekleme sıklığını burada belirlemeniz gerekiyor. İşte veri sorumluluğunuz işte ayda bir defa, 15 günde bir defa ya da her hafta bu verileri yedekleyecek mi? Bunları bunları tanımlamanız gerekiyor. Ve yedeklenen kopyaların hangi formatlarda saklanacağı ve bu formatlar için gerekli yazılımları bu veri yönetim planınızda olması gerekiyor. Çünkü her veri tipini her yazılımla açabilmek mümkün değil. O yüzden de hangi formatta saklayacaksanız, yedekleyeceksiniz. Aynı zamanda bunun için gerekli olan yazılımı da burada belirtmeniz gerekiyor. Ve en önemli konulardan bir tanesi proje süresinde mutlaka verilerinizden sorumlu bir kişinin olması gerekiyor. Ve bu kişinin de sorumluluklarının tanımlanması gerekiyor. İşte proje yönetim süresince veri sorumluluğunuz budur. Şu formattaki şu verileri işte haftada bir bulut servisimizde ya da işte Aperta'da yedeklemeden sorumludur gibi bu şekilde buradaki bölümü de detaylandırarak koymanız gerekiyor. Yine projeniz tamamlandıktan sonra verileri üçüncü kişiler nasıl paylaşacaksınız? Bunu belirlemeniz gerekiyor. Sabahki oturumda da göstermiştim. Burada bir lisanslama gerekiyor. Burada da genellikle yaygın olarak kullanılan Creative Commons lisansları. Burada uygun olan lisansı seçiyorsunuz ve başkalarının sizin verilerinizi hangi koşullarda kullanacağını tamamlıyorsunuz. Diğer önemli hususlar var yine bu konuyla ilgili. Verilerinizin paylaşılması için onay bilgilerinizi mutlaka almanız gerekiyor. Hassas verilerse katılımcıların kimliklerinin saklı tutulması için gerekli önlemleri almanız gerekiyor. Bu konuda işte veri anonimleştirme devreye giriyor. Yine OpenAI'nin bir aracı olan Amnezya gibi araçlarla veriyi anonimleştirmek gerekiyor. Sonra hassas verilerin transferinde saklanmasında mutlaka çok sıkı güvenlik önlemleri gerekiyor ki bunlarla ilgili de önümüzdeki günlerde özellikle hassas verilerin korunması ile ilgili bahsettiğim gibi 25-26 Mayıs'ta TÜBİTAK'la beraber düzenleyeceğimiz bir toplantı daha olacak. Orada bu konularda birazcık daha detaylı bilgi vereceğiz. Sonra verinin sahibi, yeniden kullanım lisansı ve üçüncü kişilerin kullanımına göre kısıtlamalarda belirlenerek burada bulunması gerekiyor. Diğer husus işte eğer patente başvurulacaksa, patent alınacaksa, herhangi bir dergiye gönderilecekse, buralarda da herhangi bir ambargo süresi varsa ve belli bir süre bunlarla ilgili yapılacak çalışmalardan dolayı verinin açılması ile ilgili bir tedbir almak gerekiyorsa yine bu bölümde bunları bahsediyorsunuz. Evet, bilgi notundan bahsetmiştim. Burada sizlere veri yönetim planının üzerinde çalışılmaya proje süresinde devam edilebileceğini ve veri yönetim planınızı proje süresince güncelleyebileceğinizi söylüyor TÜBİTAK. Ve veri yönetim planının her bölüm için projenin başlangıcında bilgi sunmanızı istemiyor. Bunlar bazı soruların projenin ilerleyen dönemlerinde de yanıtlanabileceğini size söylüyor. Ve kullanmayanlarınız varsa bu veri yönetim planınızı hazırlamada, TÜBİTAK veri yönetim planı hazırlamada veya diğer veri yönetim planlarının hazırlanmasında gerçekten TÜBİTAK Ulakbim tarafından şahane bir portal oluşturuldu. Açık veri Ulakbim.gov.tr. Araştırma verileri yönetimi eğitim portalı, mutlaka oradan yararlanmanızı ben de bir defa daha öneriyorum. Orada size bütün alanlarla ilgili detaylı bilgi sunuluyor. Ve burada proje süresince üretilen verilerin TÜBİTAK Açık Arşivi Aperta'da paylaşıma açılması isteniyor ve bu şekilde de proje sonuçlarının doğrulanması ve verilerin yeniden başka araştırmacılar tarafından da kullanılmasının mümkün olabileceğini söylüyor TÜBİTAK. Şu anda bu program için veri yönetim planını tamamen istenilen şekilde doldurmak anladığım kadarıyla zorunlu değil. Önerilmektedir diye bir bölüm var planın içinde. Ve birazcık da Argos'u anlattık. Argos evet bir veri yönetim planı hazırlamak için kullanılan bir araç. Arkadaşlarım detaylı şekilde anlattılar. Evet, açık kaynak kodlu, konfigüre edilebilir ve tüm araştırmacılar için ücretsiz. Arayüzü Türkçe'ye çevirdiğimizi söylemiştik. Ama yenilendikten sonra arayüz Argos'ta da sürekli güncellemeler yapıldı ve bazı alanlarda Türkçe kısımlarda eksikler olduğunu da fark ettim bugün de ben bakarken. Hemen en kısa zamanda oradaki eksikleri de giderip tamamen sorunsuz bir şekilde Türkçe olmasını sağlayacağız. Burada hazırlanacak bir veri yönetim planı makinece okunabilir oluyor ve paylaşılabilir oluyor. Bu çok çok önemli. OpenAIR ve Avrupa Açık Bilim Grubu'yla bağlantılı olması çok önemli. Ve bütün standartları sağlaması çok önemli. TÜBİTAK'taki arkadaşlarım ve Argos ekibi de en kısa zamanda çalışarak bu TÜBİTAK veri yönetim planında Argos'un içine ekleyeceğiz ve bu şekilde de artık siz TÜBİTAK için veri yönetim planı doldururken Argos'u çok rahatlıkla kullanabileceksiniz. Bu hazırladığınız planı arkadaşlarınızla paylaşabileceksiniz. Beraber doldurabileceksiniz. Başkaları da aradığı zaman sizin planınızı orada bulabilecek. Şimdi başarılı bir araştırma verisini tanımlayacak olursak, evet, yeniden kullanılabilir olmalı, tekrar üretilebilir olmalı, gözden geçirilmiş olmalı, anlaşılabilir olmalı, atıf yapılabilir olmalı, keşfedilebilir olmalı, erişebilir, korunur ve çok iyi şartlarda saklanır olmalı. Niye araştırma verisi? Araştırma verisi gerçekten bir araştırmadaki aslında gizli hazine. Araştırma sonucu çıkan makaleden bence çok daha değerli ve ömrü çok daha uzun, birçok insana çok daha uzun süreyle ihtiyacını gideriyor. O yüzden araştırma verilerimiz çok değerli ve çok kıymetli. Çünkü iyi araştırmalar her zaman iyi veriye ihtiyaç duyar. İyi veriyi oluşturmak için de uluslararası standartları kullanmamız gerekiyor. Uluslararası araçları kullanmamız gerekiyor diyerek ben sözlerimi burada bitirmek istiyorum. Hepinize teşekkür ederim. I'm stopping my sharing. I finished my presentation. Adamantios.
Thank you very much, Gültekin. I think that we had in these 2 days the opportunity to get more experience in listening to Turkish language, so it might be that at some point I will be able to speak some words in Turkish. I would not like that we extend the event. So, and now we have only 2 minutes left. And what I would like, on the other hand, to not lose the opportunity is to ask a question to all the panelists. And you can, so I would like that more than one of you would come back with some answers. And I checked this also with few participants that it seems like it's a very important work, this of curating data of projects and research data. And the thing is that most of us, we are either project managers or researchers or scientists. So we have been, some of us or all of us at some extent as part of our own research activities, exposed to the issue of data management, but for carrying out some experiments or for publishing something. Now, the thing is that, and the question to you is that, it seems like that we will either have to invest serious time and efforts and resources, each of us that are involved in research projects and research. And this is something that we may be currently lacking the skills, and it might be something like data literacy skills. And the other thing is that we might simply hire in our future projects. The good thing with projects, research projects and horizon projects, is that you can allocate some category and then hire people who will be dealing with all these things without needing us to take suboptimal or even wrong decisions. So if you were now to give some gut feeling answer there, what do you think is best? Actually, optimally would be that we would be hiring specialists for these, but also we would also increase our literacy and our awareness about this. But what would you provide us as some advice? And you don't need to agree anonymously to this. So Gültekin and Eli can start, but also Ebru and Harry and Manolis and everyone else from the panelists.
Eli, ladies first.
Okay, all right. Thank you. Thank you very much. It's Ebru. We have Ebru with us as well. She's a lady. She was yesterday a panelist, so maybe she also wants to add.
Gültekin, I think he is very diplomatic because he would like someone else to test the waters with an answer.
Okay. All right. So maybe we realize that we are talking about a new standard, as I mentioned yesterday. So open science is a new standard. It means that we have to. It means that we take all the different practices that we were following for all those years, as also Emily showed, but we improve them first. We improve them, and this is where infrastructures and services are important to make those tweaks in order for those improvements to happen. And next, we as researchers have to follow extra steps for preserving our data and for sharing our data. Right, so it's something open science has to do and has to be applied to different levels. At the national level, everyone has to be prepared, provide the infrastructures in order to facilitate open science, and not only at the national level, but also to facilitate researchers who are working at the European level, right? And then, so national level is important, local level is important for research performing organizations like universities, like research centers, to to provide trainings and to create increase capacity building, like data literacy, as you mentioned, is very important. So there are different aspects and different levels. For research performance organization, for example, is this. For researchers themselves to follow those practices, to try and implement them and the will. So this is why we have different networks that can support everyone in this process of getting familiar with open science, open science practices and their implementation. Not only OpenAir, there's RDA. There are so many globally and European fora that you can go and get advice from and link with them. for that. So I would say that this is something multidimensional, as I always say. It has to do with different aspects. It has to be taken care of by different stakeholders and at different levels. So it will take time. This is what I want to say. It will take time, but it's very encouraging to see what you're doing in Turkey. Like TÜBİTAK is developing Aperta, which will help researchers limit the costs that are needed. So if we could just enhance this dialogue between researchers, as you do in this project, like how all the different people can talk to each other and get a grasp of their needs, to prioritize their needs and build on them. Sorry, this took longer, but yes, that would be my initial answer to that.
Thank you so much. Your answer is really nice, and I would like to contribute your answer. When we are talking about open science is not the only word. Open science is a future of the science. So we have to invest, we have to improve ourselves. How can we open our research output? Because we need the cooperation, we need to work together. We have different problems as a world. For example, COVID-19. We are trying to solve the solution. We need a vaccine, we need a medicine. So we have to work together. Why we are doing this as an open air? We have to find the solution, all these things for the world. We are working more than 11 years. We improved, we developed, we built many different services for the researchers. Why? We have to find the solution for the world. So open science, future of the science. Future will be open.
Thank you, Gültekin. Ebru.
Yes, that's great. Gültekin and Eli said the summary of the open science, I think. Like Eli and Gültekin, I would like to say dialogue, exchange, and collaboration at all levels are essential for implementing open science. This COVID-19 pandemic has given a fundamental
Is it only my end? I cannot hear.
Yeah, there are some problems. I also expect some problems with the internet quality. We may close the videos. It's a pity, but let's close all of us the videos so that we will at least gain quality on sound.
Yes. Ebru, baby, you can close your video.
Yeah.
We lost Ebru.
Yeah.
Who is with us? Harry?
So perhaps, as I said, I wouldn't like that we extend the event more. This was also my aim from the very beginning in the morning. And I have to thank you, all of you, for these 2 days. And is Ebru now with us or not?
Yeah, yes, I'm with you.
Yeah, please, Ebru, we listen to you. Yeah.
Okay.
Yeah.
I'd say dialogue, exchange, and collaboration at all levels are essential for implementing open science, like Gültekin and Eli mentioned it, because the communities of individual discipline as well as neighboring disciplines must identify examples of best practice to communicate them and learn from them. The COVID-19 pandemic has given a fundamental trust to open science, and this potential must be used fully. Opening up research data has shown how science works with openness. This is very, very important. But I think the pandemic has also shown up some deficits. Yesterday I mentioned them, especially in the area of science communication. Here, the lesson has that In the past, it has not been made sufficiently clear how the scientific cosmos operates. This must be urgently improved so that public gains on the informed trust of science, I think. That's all for me. Thank you.
Yeah, and I would like that we stay with these concluding words of Ebru. And again, from my side and from all of us, the organizers, many thanks for the attendance. And there is also, as I see, a SurveyMonkey page so that you would all go and evaluate the experience of the event. And many thanks again. Many thanks. Bye-bye. Bye-bye to all.
Bye-bye.
Bye-bye.
Thank you so much.
Bye-bye.
Bye-bye. Bye-bye.
Bye-bye. See you.